It will be a fireside chat, Advanced Material Pandemic and Future Preparedness Taskforce, with John Hoffman, CEO of GSMA, and Dr. Zina Jarrahi Cinker, Director General of AMPT. So please, Zina, turn on your video and unmute yourself. Okay.
So Zina.
John, we're social distancing,
we are
right?
Social distancing.
We're social distancing, but we can't see you right there. Okay.
Check distance. There we go.
Yes, we are distancing and we're seeing each other.
So thank you for organizing this inaugural conference of the AMP Vision Accelerator. Now, we're all here today because of your vision of using a platform for accelerating the use of advanced materials such as graphene to help address this pandemic, but also other global issues that may arise. So if you could sort of help us understand what AMPT is, why you did this, and maybe a little bit where we're heading.
Absolutely. And first of all, I thank everybody who is here today. Also, thank you guys for doing this in person, obviously social distancing again. AMPT, Advanced Material Pandemic and Future Task Force. One of the reasons why we started this was the lack of coordination strategy we saw. What is AMPT? AMPT is a public interest initiative that we started to use advanced materials to solve some of the issues that we have, global issues that we have, such as global health emergencies. Why we started this a few months ago, as you know, when pandemic was at its peak, you remember those days,
Very well.
It was in the beginning of March, and we started seeing this issue, which was people coming to us and having requests. For example, this actually, I'm going to give a very specific answer to that one, an example for that one. We had people contacting us because they were looking, for example, for putting graphene or other advanced materials in masks. Some people were working on diagnostic tools, etc. And they were having a lot of trouble navigating the space with their environmental health and safety issues or regulatory compliance, etc., testing, access to live virus. And as we were trying to help these people with the effort that they had on their way, we realized that there are a lot of issues in this sense, because we noticed that a large number of people in the graphene community, everybody was trying to put graphene in masks, right, which is a waste of effort and energy in a lot of cases, because we're seeing startups popping up that their whole business case was, how can we put graphene in masks? It's not a paved path. You know, it's not something that there are companies that we're going to be hearing from them today. They've had years of experience in fabrics, etc. But we realize that people are trying to help, right? If you're a business, you're trying to help. And one of the problems that they're having is that they don't know that there are other opportunities. Right. We went to nurses and doctors, and when we asked them, okay, hey, we're making you better masks, they actually said, guys, we don't need better masks. We need masks. We had wonderful masks before, if we just don't have them right now. But if you want to solve a problem, our goggles are fogging, for example. Mm-hmm. Can you do something about that? And that's one of the solutions that definitely graphene can help. We realized that there was this lack of coordination and long-term vision for this, because this is new to us. It's changing our world, it's creating opportunities, but we're all doing this work in silos. For example, especially around in the March and in April timeframe, we started seeing a lot of folks that were redoing each other's work, even in the scientific community, because the work was not even being published fast enough. So we thought that we actually had to create this coordination strategy platform on an international basis, crossing boundaries and country borders, for everybody to come together, share a vision, share the resources, share the knowledge, and create a platform where we can all work together to create a roadmap to use advanced materials to help in the post-COVID world. Because again, our needs are not just PPE and diagnostic. Our world is changing. There are going to be many, many different opportunities, and we're going to be doing with AMPT.
So this really is a coalition of the willing, isn't it?
Yes, it is. It absolutely is. It's a completely volunteer-run organization. Everybody who is a part of AMPT is come together around this vision, because that's what they saw in their own path to add value, to also benefit from it. And we have right now, I'm very, very proud to announce that after 3 or 4 months, come on, we have 15 country chapters. Right. We have over 60, I think actually by now 70 regional chapter members, and we have 10 active working groups, everybody working together with this grand vision of how can we use our materials to solve and fast track solving some of humanity's most immediate challenges.
And even today, we're expecting 150, 200 people from around the world to come together for this accelerator to learn a little bit more about AMPT and how they can become involved into the future, which is outstanding. So tell me, how did you, because it really was you starting this grand vision, how did you assemble such a renowned list of global leaders?
Good question. I know that looking at our steering committee, and also if you look at our some of our regional chapters, you see it's very 2D and graphene heavy.
It's really doctors.
And it is also, yes, it's very scientifically and also very 2D heavy, which is, it was not by design. It was, we had to start, we started with friends, we started with colleagues that we worked with. So I've been in the graphene field, so I started with my colleagues and my friends who have been supporting me for such a long time. And at some point when we brought people together, it's not my initiative anymore. It is, as you mentioned, the coalition of the willing. It's everybody who's coming together and building this. Every single person who's making a contribution has a piece of this puzzle.
And it's really very global as well.
It is absolutely global. That was the whole point, was this is a time, this is the one time that we need to come together because we've got an issue that is impacting all of us. And it's giving us this platform to actually communicate on a different level.
So what do you see as some of the near-term milestones for the platform? What do you hope to accomplish in the near term?
Our eye is definitely on creating a roadmap. This roadmap is going to be available to everybody, and it's going to be a guiding force behind what we are doing. And some of our near-term milestones, I would have to mention that the work of some of our wonderful working groups, the EHS working group, the roadmap working group that we have, the work of our library of knowledge, creating these reports, creating this kind of a base of knowledge. We have a knowledge hub. We're creating databases that could be available to everybody, that they would be able to communicate. But our eye is on this roadmap. Everything we're doing has to feed into this roadmap, and we will be hearing from our some of our working groups today that we're presenting on there.
And you know, gaze into a little bit. What does the future look like?
The future for advanced materials, I believe that, I say, you know, there's a silver lining in everything. Right? The silver lining in this pandemic is the fact that a lot of times in the past, when, especially with graphene, you would go to people and would say, okay, include graphene, it's going to add some benefits and add value. They would say, well, if it ain't broke, don't fix it. Right. So I say, it's broke now, can we fix it? And while you're fixing it, can you please evaluate our advanced materials?
Every crisis is an opportunity.
Exactly. I think that this is the right time for us to include advanced materials in the innovation path for the next few years, because again, I have to emphasize this. This is not just about PPE diagnostic and antiviral coding. There is a whole new set of needs, and I'm going to give you one example just to kind of clarify that. When we go to retailers and we ask them, hey, do you want antiviral coding? They said, guys, we don't need antiviral coding. We're cleaning our points of sale system so much with alcohol. We have 400% more transactional fail, which means that something not virus related, but it's going to be needed. Plexiglasses, for example. Right. Yeah. That's something that coding in this area with advanced materials can definitely help.
But now, you know, this pandemic, we're going to get through it, but this isn't, soon. But this is not a one and done kind of an initiative, right? I mean, it's not focused just on solving COVID related issues. I mean, we see some kind of a longer term roadmap, right?
Absolutely. We had 3 pillars when we put together this initiative. The first pillar is creating a network. We have a network of resources in an advanced material community and beyond. The second pillar that we have is our library of knowledge. We need to know as much as we can about what has been published, what do we know, what has not been published that we know about. Let's get together all the knowledge that we have it as a database, have access to it. And then the third pillar that we have, which is very important, is the map of needs. We need to map out what are the needs. What are the needs of the event industry? What are the needs of the restaurant industry, the tourism industry the next few years? And when we put those things together, it allows us to actually create this roadmap. The most important thing is that we are using this engine that we're creating right now to solve the global health emergency, or facilitate the development of some of these. But the same engine could be put in many different vehicles depending on the need. And I think that it is creating this urgency that we have right now to create this global platform for everybody to come together. This is a building that we're building. It's not going anywhere.
So we're in the foundation stage.
We are in the foundation stage, and we're starting this foundation, and it's not going anywhere. We are going to be able to use it for the purpose of expediting innovation.
So it's a volunteer initiative, but we really can't continue without funding, right? So we have to secure some kind of an operating funding source going forward. You know, some of the things that come to mind, we could crowdsource. You know, we could look to friends and family. It's great. It's always a great way. Government grants. And not necessarily government grants, you know, just for global initiatives. We can actually go toward state initiatives as well.
That is true.
Or even regional.
And national, yes.
National. So philanthropic organizations, rich aunts and uncles. I mean, I think
we
got all kinds of opportunities. But we have to move from this volunteerism, coalition of the willing, to some sort of a long sustainability.
Absolutely. You're actually bringing up a very good point. You remember in March when we were starting, people were asking us, when we start this, people were asking us, where is the funding? Why are you guys doing this? And we said, why should there be funding for us to do what we are supposed to be doing? It is our responsibility. It is our duty to do something. And that was the story of AMPT for us to start this. Was we don't have the funding right now, but it is our responsibility. We will do it. We're building the foundation for us the next few months to be able to go after all sources of support. And I encourage everybody who is attending this meeting today, if you know of any sources, especially our regional chapters, we're going to be activating national funding opportunities for us to be able to for AMPT to be able to create a sustainable model in the future. And we welcome everybody to contact us, let us know if they know any sources of funding.
So here in the United States, you know, baseball has been, well, you don't know, but baseball has been delayed due to COVID. So we just started a couple of days ago. And a few years ago, there was a great movie called, now I can't think of the name of the movie. But a baseball movie. It's a baseball movie. Anyway. But it's Field of Dreams. Gosh, Field of Dreams. And it was all about building a field and they will come. So we're building AMPT, and we're going to build it for the future. And we are in the crowdsource funding. We have to get some operating capital at some point in time. But that doesn't matter because we're out there and we're working now. So as the chair of the steering committee, I would implore all of you to think about, you know, how could you help us? So any ideas, bring them to Zina, bring them to myself, no matter how wacky, because
we love wacky ideas.
We wouldn't be doing this if we didn't love wacky ideas. All right, so you know, our time is, you know, just about up, but what's in store for the rest of this program today? Sort of just give us a little bit of a view from your eyes.
We are going to be hearing from a lot of wonderful people, experts in the field of advanced materials, as well as our working group. So this is very important. We call this a Vision Accelerator because we wanted all of you to participate in this meeting, to understand what AMPT is doing, what our working groups are doing. And we have an open network. Anybody who wants to be a part of AMPT, they can go and apply to become a part of the network. Our regional chapters, our working groups, so we're applicants in this network. And they came on board, they saw a piece that they could actually carry, they picked it up and they're building it, like Kazi, like Laura. And we want to emphasize that we are building a partnership here. The AMPT does not exist. AMPT is the people who are building it.
Right.
That's basically who we are. So I really would like for this, the next 3.5 hours, I would want everybody to listen carefully and see opportunities, see yourself and your work in any of the presentations that are going to be ongoing, and contact those working group members, contact myself, contact Laura and AMPT. And I encourage you again, if you haven't applied to become a part of the AMPT network, please do apply.
Well, Zina, thank you for this great overview. Thank you for organizing this session today. But I think more importantly, on behalf of all of the volunteers, thank you for this vision of that you really started to take us into the future, and who knows what the future may hold, but it's an exciting future.
Thank you so much, John. Yes, I came up with this tiny idea, but again, AMPT is the people who are making it. It is you guys. It is the people are from our regional chapters and our working groups. They are the ones building this. So thank you again, everyone. And I'm going to give it back to Laura. And I'm going to mute myself and stop my video.
Over to you for our first panel.
Okay, so hello everyone again. So thank you, John and Zina, for talking about AMPT and what AMPT is. So we can start with our first session. That will be a panel called Latest Scientific Development from Graphene Institutions Worldwide. It will be moderated by Carlo Iorio from ULB, and will speak Dr. Frank Koppens from ICFO, Spain, Dr. Vladimir Falko from the University of Manchester from UK, and Dr. Kari Hjelt from the Graphene Flagship from Sweden. So please, if Frank, Vladimir, Kari, and Carlo, can you unmute yourself and turn on your video so you can start your panel?
Hi, Laura. I hope that you can hear me. I can see the video of Frank, Kari. I am trying to look for Vladimir somewhere.
Yeah.
I guess so. Vladimir has not is not on. Okay, now I can see also Vladimir.
Great.
I hope that everybody can hear me. So I am the moderator of this first panel on this event. I should say that it has been a big effort of Zina and yourself, Laura. So to organize this event, it was not very easy, especially it was during the summertime and also in a very short time. But I think that there are a lot of questions that we want to answer. There are a lot of questions that we want to bring to everybody in order to help in answering. And of course, we have on top of it this crisis that basically was at the beginning of the reflection in AMPT. So I am delighted to moderate this panel about the latest scientific development from Graphene Institution worldwide, and to share this panel with Professor Koppens from ICFO. I will try to pronounce correctly in Spanish, that is Instituto de Ciencias Fotónicas. And Professor Koppens is leading the quantum nanoelectronic group at ICFO. Then basically we will ask Professor Koppens directly to introduce himself and tell us a bit more about his activity. Then we have Kari Hjelt, Dr. Hjelt from the Graphene Flagship, so he's head of innovation. So Kari, hi Kari. With Kari, we shared also a wonderful trip in the United States where at an event organized by Zina. I think it was last year or 2 years ago, I don't remember. And Kari is in charge of the innovation processes for the Graphene Flagship. And then Professor Falko, I lost the video of Professor Vladimir Falko from the University of Manchester, and he's a theorist about especially condensed matter. So I will just introduce briefly myself. So I am a part of the Graphene Flagship, and I am working at University of Brussels. In general, I am working on composite with graphene that is some sort of advanced material with a specific reference to space applications. And also I am leading a company, so I'm even an entrepreneur that do technology advisory. So please, I will start with Frank, Professor Koppens. Frank, I think that we can just call us by name. If you can just briefly introduce yourself before then beginning to discuss about the scientific development on graphene. Please, Frank, tell us a bit about your activities.
Okay, yes, I'm Frank Koppens. I am group leader and professor at ICFO, the Institute of Photonic Sciences. We are just south of Barcelona. And so our institute has about 500 people that are working all kinds of applications and science with light, anything related to light. And in my group, we investigate graphene devices or also two-dimensional material devices that are used for all kinds of applications. For example, cameras and imaging systems, data communication systems. But also we work on wearable devices that can be worn just on your body or can be integrated, for example, in your clothing. And so I will explain about that later, but those are activities in my group, and I'm also involved in the Graphene Flagship as the work package leader for optoelectronics, and I am also vice chair of the executive board of the Graphene Flagship.
And can I ask also you, what is your involvement in the AMPT, because you are part also of the steering committee?
Yes.
And so can you just introduce your activities in the AMPT steering committee, even with Kari, but Kari will introduce himself later.
Yes, so well, first of all, I was extremely happy that I was asked to join the steering committee, because this initiative is really amazing and really essential in these very difficult times. I actually live, near Barcelona, and a month ago we were thinking like, oh yeah, this COVID is almost over, and as you see now, you hear in the news in Barcelona, we're again in trouble. So I am involved in AMPT in the steering committee, and I'm also trying to help with the roadmap and help with the alignment with the Graphene Flagship.
Okay, thank you, great. I will now ask Kari to introduce himself. This panel is composed of people like Frank and Vladimir that are more intensively in the research and development, and Kari on the other way around. We can say, Kari, you are the person that will try to get what is coming from the research group in the world, and especially in the one that are involved in the Graphene Flagship, and then you try to help them bring to the market. So tell us a bit which is your involvement first in the Graphene Flagship, then why you think that AMPT can be integrated in what you are doing in the Graphene Flagship.
Thanks, Iorio. Yes, my role in the Graphene Flagship is, as I said, the head of innovation. So I try to boost the innovation and commercialization activities in the flagship. So see that everything is done in the optimal way to get things on the market and forward from the research. And also participating in the management panel executive board actions. So Graphene Flagship is, of course, also, sorry. Okay, I heard something. Graphene Flagship was, of course, a very large initiative, and it's not only graphene, it's also related materials. It's good to remember. So it's other 2D materials as well, although graphene is, of course, in the center of it for sure. In any case, we have a lot of actions in the Graphene Flagship. We have 15 different scientific work packages, so ranging all over a vast amount of different application areas, which are, most of them are somehow applicable actually on this work as well. So I think And also maybe my background is good to explain that I did my postdoc in the biomedical systems, biochips and miniaturizing on silicon, on sensors, micromechanical sensors. And then I was in Nokia for 12 years, leading also laboratories there and building up laboratories like smart spaces and Internet of Things and so forth. So I sort of have a relatively good background on this exercise, because I think that what is important is that we really look at the larger picture. So what are the commercial spaces that will be changed by this pandemics? And I think we will discuss more of those, but if you think about user experiences, our user experience, of course, what it means how we interact with the spaces around us and with the items. And so how we interact with when we go to some public place, but also with our computers. And that will change a lot, because this pandemic has caused us to be on the fast track on the remote working, and also thinking the mobility solutions all new, like how we need our remote working and remote communication tools. That all will be changed, and that's the main question for me. And I'm glad to work with such esteemed specialists and scientists like for example Frank and Vladimir, who then can actually say what is the solution for each and every different problem that we have. But on the whole, this is the big picture that we will change a lot of commercial reality among us, not only now, but 10 years to come.
Thank you. Now, of course, we will get back to the topic that you have already spotted later during the discussion. So, Vladimir, you are a theoretical physicist, so you are a theorist. What are you doing in your daily job on condensed matter at University of Manchester? And also, why do you think that maybe AMPT can help what you are doing in a more general sense? Please.
So I'm, do you hear me?
Yeah, maybe if you can have the volume a bit up, I don't know, because it's, at least to me,
can you hear me better
thank you.
now?
Yeah,
Yeah,
this is perfect. Thank you.
So I'm a condensed matter theorist, but I wear several hats at the same time, because I'm also director of National Graphene Institute, which is mostly experimental facility. It is actually a platform for collaboration between academics across the UK and across Europe, and collaboration between academia and companies. Also in Graphene Flagship, I'm leading work package on enabling science, which is one of few in the Flagship that focus work on fundamental research. And in both the Institute and in our work package in the Flagship, graphene is no more the main object. We mostly work with other two-dimensional materials, those which are stable enough to work with monolayers, bilayers, or also combine them into heterostructures. And in those activities, we search for new functionalities that heterostructures can offer, in addition to what we already know about individual monolayers, and using the composition of materials in heterostructures to control optical properties, to control the range of optical activity of heterostructures. And we also are now busy with a new direction in this topic, which is called twistronics. That is choosing or controlling the angle between the alignment between two adjacent crystals to create periodic patterns called Moore patterns, and affecting this way the electronic and optoelectronic properties. Also, I just want to point out that we run a dedicated journal. The Institute of Physics has a dedicated journal for two-dimensional materials. It's just called Two-Dimensional Materials, where all this kind of research is reported and it became quite a popular venue for specialists to publish on this topic.
Thank you, Vladimir. And I want to take advantage just to begin our discussion about what has been evocated so far. So we are speaking a lot about graphene, but basically there is also some other, we can say, advanced material, 2D materials that are becoming more and more of interest. And I want to ask you a question about the science, because this panel is dedicated to scientific development. So, so far, and especially in the graphene flagship that now is entering, we can say, in the more commercial, more market uptake phase. We speak a lot about commercialization, about the application, but especially Vladimir, I am beginning with you first. What do you think about the science in advanced materials? So in the sense that, do we have still some unknown that can be of interest for future analysis? So what do you think that can be, and you already spotted some of the pathway, which can be the future of science in the graphene, but also in advanced material or new material. So for the moment, we will speak later about the application, and especially by reference to the pandemic. But if we want to do, and this is a question also for Frank, if we want to just say to young scientists, young researchers, there is still some very good research, there is some gaps in knowledge, what you will spot immediately in few words?
Unrelated to pandemics, there is the new area in 2D materials, including graphene, which is called twistronics. So this is changing the alignment between two adjacent layers with a high precision. And as already was discovered in graphene, in heterostructures of graphene with hexagonal boron nitride, and also twisted graphene bilayers, this induces new functionalities, new properties that graphene itself does not have. There were several big splashes in this. There was observation of superlattice effects in graphene heterostructures with GBN. Observations like the Hofstadter butterfly spectra in magnetic field. In twisted graphene bilayers, new phases of electronic matter were obtained, which are not specific for graphene at all. It has been shown that one can actually make graphene superconducting, which is very unusual for carbon, unless carbon is doped by other materials. And this is the whole new area which now explodes into other two-dimensional materials. Last year, there were a series of publications on observations of superlattice effects for more superlattice effects in heterostructures of transition metal dihalocogonaids, where the superlattice mini-bands were observed not just individually for electrons and holes, but for actually excitons, the bound electron hole pairs. And this field is now extremely fast developing, not only because of it's interesting, but it's also because the multiplicity of material options that one can employ. And similarly, there are now new types of materials implemented in 2D materials research. There are magnetic materials which became available and show enough stability to be studied experimentally, and making devices out of those for very spintronic applications. And combining magnetic functionality with optical and maybe even superconducting materials within few nanometer thicknesses, an extremely exciting opportunity, which other materials do not really offer.
Thank you, Frank. In the photonic side, do you have some, I can see also there is a question, and I think that about the optical properties of the SARS-CoV-2, and electrical properties? Do you have, and you can integrate on photonic side, what we can say about the science to discover, possibly related to the pandemic, but also I insist because in the Graphene Flagship, but also AMPT is trusting a lot also in creating a young generation of scientists. So what we can give them as an advice for the future in science, and possibly related to the optical and electrical properties of the SARS-CoV-2. Can you a bit tell us about this?
Yes. So the way I see graphene and 2D materials is really that it's like Lego. Okay, Lego that we play like as kids, right? So you can build something with Lego that you want, and the same is here with 2D materials. You can really think of a property, an optical property, for example, or a device that you want to build, and then you can build it with those 2D materials atom by atom. So we built these heterostructures with precision of a single atom, and that is really amazing. So we do really atomic scale Lego. And in that way, for example, in optics, you can make extremely sensitive optical sensors that are sensitive even to single molecules, and a virus is a lot larger than a molecule. So you can make sensors that are also sensitive to the type of chemical bonds, and that have extreme strong interactions between the light and the materials. And that's really possible now because of the 2D materials. So not only the properties, but the fact that I can build a device atom by atom. That's one comment. On the other hand, this is not anymore only a scientific effort in the sense that it has already been shown that you can make not only one device, you can make millions at the same time on one chip and integrate those with, for example, CMOS electronics that is also used in your smartphone. For example, the image sensor, the camera inside your smartphone is based on silicon technologies. And you can integrate now 2D materials with those type of technologies to create new types of image sensors that can also be used for detecting viruses and bacteria, etc. And there is already several companies operational, including one of myself, as well as production facilities.
Okay, thank you, Frank. So we have spoke a bit about advanced material. We have understood that there is a lot of things still to do, and maybe even things that are opening up and was not foreseen at the beginning of this, we can say, revolution. I want to get back a bit with Kari about the pandemic, because if I'm not wrong, Kari, when you introduce yourself, you spoke about the fact that the materials are important and materials can contribute, but I captured also an integrated vision about the use also of digital in the sense of informatics. Do you think, and the question of course is also for Frank and Vladimir, do you think that graphene or the two other material or the 2D materials, advanced materials in general, can contribute alone to the also to the pandemic, but we can say to the medical sector in general? Or maybe in the future we should expect that this material, exactly, I will take a bit the image that Frank gave before, it will be like a Lego that we will put the material and then digital, the informatics, we can say artificial intelligence, it will be, we can say, a global view. So what is your opinion? What will get out from this crisis in terms of revolution?
Yeah, I think as was begun with this whole meeting, it was this, every crisis is opportunity, in a way that it really drives us, it forces us to do things in a new way, in maybe in a better way. And I think now, as I already briefly mentioned, this, for example, this mobility, how you interact with the information and other people, how you communicate, how you move, that's going going to change drastically because of this pandemic. And that, of course, embeds all the questions about how you interact with the spaces around you. I mean, what are the user interfaces? And graphene can both act as a sensor and also like an important part of the like a different kind of, for example, touching surfaces that you interact with the devices. So it's a very important for both censoring the molecules and environment, but also sensing your touch and acting as an intelligent layer around you, even in the clothing or devices around you. So you can do a lot of different kind of sensing applications with 2D materials. So that's one thing. Then there's of course a lot of things in the mobility, for example, faster optical networks. That's also something that we work with the graphene. So that is some of the speeds that we have now shown with the graphene related technologies are much faster than could be attained by any other technologies at the moment. So it enables us, new materials enable us to have better communication, for example. But I would say that these are the sort of quite low-hanging fruits in a way, because they are already in the pipeline, they are coming. But then we see a lot of other things like surprising effects on the developments that we already started. Very shortly, an example of air filter. We have a big spearhead project with Lufthansa technology about air filtering in the cockpits and in the fuselage of the airplanes. And yeah, of course, that's important problem, and graphene can be a solution because it actually can be a very interesting filter, can be done by utilizing graphene's ability to be thin, and you can, do this kind of purge of the filter very fast. But now everybody's talking about air filters. I mean, filtering the air in different public spaces is becoming more and more important. So suddenly you have a lot of commercial pull for these kind of new ideas. And I think this is essential. We have a lot of things that we can do, and there seems to be now a lot of question marks in the commercial space that, okay, how can we solve this problem? And that's the thing that actually will explode our possibilities.
Thank you, Kari. We have only 2 minutes left. So just a quick question to Frank about because you are also part, even with Kari, of the steering committee. So there is a lot of going on everywhere in the world, but there are also institutions that are doing stuff independently. How we can do AMPT can help to bring the different institutions internationally spread it in the world to put together and to create a critical mass, a bigger critical mass about advanced materials. Just 30 seconds, your opinion about that.
Okay, I hear from a lot of colleagues that they're very eager to have access to testing facilities. So coordination amongst the institutions on how to access testing facilities would be a great thing. The second one is some colleagues directly work with hospitals. I think that's a great opportunity that scientists that have only access to a lab can actually then cooperate with more medical type of scientists that can then make the link to hospitals. So basically we should really cover the full spectrum of scientists. So not only the material scientists, but also the medical scientists and people that work in testing facilities.
Thank you. And I think that this will also be a nice contribution on the roadmap. We discussed about the roadmap. I will discuss later about the roadmap. I think that the time is over. So let me first thank you for your very interesting comment and especially the inspiration for a new topic and also to the inspiration for what is the point of the debate about not only pandemic, but also about the new pathways for science in advanced material. Just one comment, Laura, before I leave you the floor, is that I can see that there are some questions on the chat that are a bit more technical, and I see that there are questions for Frank, for Vladimir. Please feel free, because we will not have time now to answer live, but feel free to answer directly on the chat, or if it's the case, to continue your discussion even later. This is also why we are here. So thank you to Frank, Kari, and Vladimir. It was very nice to have you in this panel, and I guess, Laura, that I will be the next speaker too. Thank you so much.
Yeah, okay. So
and thank you
we have a couple of minutes for just one question, maybe for Vladimir, if you're ready, if you can unmute yourself. We have a question for you. And
yes,
John is asking, yeah, what is
so there is a question from what is your manager doing with regards to COVID research and mitigation? Vladimir, do you have some clue about this?
Yeah, I was just typing the answer. So
okay, yes.
really, it's not really about graphene research. It's very broad. And from the day one, Manchester was very active on this. For example, university gave to NHS equipment for oxygen storage and systems for pumping oxygen and for passing oxygen. We have about 70 projects across the university. They're all pretty small and fast response, meaning the research and delivery is expected to be within 3 to 6 months. And this is very broad across all kind of activities, from developing filters to developing techniques and equipment for spraying liquids with highly economic systems for spray. But very few are related directly to graphene. And what I would like to warn those who work in graphene and other materials is, if you don't understand anything in viruses, don't pretend. Just it is really for the professionals who understand what is needed and how to do it, rather than to try to be useful without understanding anything about what is needed and what is real. I think that is the message that I actually wanted to deliver anyway.
Thank you, Vladimir.
Of this meeting.
Thank you, Vladimir. And it's really nice also to have a reality check about this kind of topic, because essentially, of course, the crisis and the pandemic create a lot of, we can say, confusion, even in very good faith, about every one of us in different topics. So, Laura, please take the floor.
Yeah.
And I think that we are finished. Thanks to also, I can see that we have more than 100 people listening. Thanks for the questions. And please, we will try to answer also on the chat.
Great. Thank you, Carlo. You've been a wonderful moderator. And thank you, Vladimir, Frank, and Kari too. So, guys, we're doing a lot of great questions. Some of them are really, really technical. Don't worry, we will save them. And you can contact us also in the end, at the end of our conference, so we can start chatting and discussing all of these super interesting topics more in depth. So don't worry for that. But right now our time are a little bit tight. So let's introduce our next session. That will be a presentation from one of our working group that will present their work on the roadmap. And we'll be presenting Dr. Lucia De Logu from University of Padua, Dr. Gloria Guidetti from Tetra Pak, and Dr. Carlo Iorio from ULB. So please, if you can unmute yourself and turn on your video.
I can see Lucia and Guido. Yeah, sorry, but I promise that this will be my last intervention. I don't want to transform this in a one-man show. So I will be quite brief, and then I will give the floor to Lucia and Gloria. I think that we can win some time by skipping my introducing myself, because I already did a few minutes ago. So I will introduce the main question, but also the main goal of the working group on roadmap. So the main point, because Zina already during the session before were thinking about and presented that we need a roadmap. The roadmap will be central also to the organization of the activity of the AMPT, but also following what Vladimir was saying, we should always think about a reality check. So that's why we discussed about why we need a roadmap and do we need a roadmap. So first of all, I want to tell you about where we are. So concerning not only our group, our community, not only the advanced material, but I want to just to spot some point about where we are in the world, in the how the mankind is affected by the pandemic and what the pandemic has revealed. So basically, the pandemic revealed weaknesses and even strengths in sometimes in what is the healthcare management system of the entire world, but also about the preparedness of the entire world in acting quickly. So this is one of the things that I guess have you know, sometimes even was astonishing for many people, because even in what are considered very, very developed country, first world country, actually this pandemic revealed some systemic weakness that nobody expected. You know, when we spoke about weakness about the healthcare management system, we are usually brought to think that in developing country, in underdeveloping country, this kind of problem should arise in a very strong manner. But now we see that according and the pandemic leveled all this kind of idea, all this kind, we can say also, of illusion. So basically the pandemic revealed the weaknesses, but also the pandemic is having a huge impact. And we should not only think about the medical in itself. I agree with John Hoffman, with the comment of John Hoffman, that in one way or the other, in this month or next month or in a couple of months, there will be still some problems, but one day this emergency phase will end. But the point is how our life, our habits, our behaviors will be changed, and if they will be changed. Also, pandemic, and we know from the journal, the newspaper every day, is having and is affecting economy at the worldwide level, and what is even more important, because it's surprising, independently of the size, power, and wealthiness of the different countries. This, I think, is the aspect, that's why I'm repeating this, that has shocked me a lot. I never thought that the very, very developed country, Europe, United States, Canada, were touched so strongly by what was happening. And also, pandemic has in some way, and believe me, I don't want to be disrespectful for the death tolls and for the suffering of the people, but pandemic has also positive aspects, because it's a big opportunity to learn from our weakness and prepare for the next global scale problem that cannot necessarily be in the health sector, can be, for example, in climate change, can be in the management of the resources, and can affect other sectors. So in general, why we need a roadmap? We need a roadmap because we need to build a vision. And can you go on, please, Laura? We need to create, Laura? Okay, we needed to create a vision. And as we were discussing in the panel before, so basically this vision, we have understood that it should be holistic in some sense, in the sense that it cannot be driven only by a sector, it cannot be driven only by advanced material, but should involve, for example, if we refer specifically to the pandemic, to medical doctor, to virologists, epidemiologists, but also, as Kari was saying, about the use of digital integrated platform to put all together. By the way, this is also why we think that the main value of AMPT resides essentially on the fact that AMPT is an intersectional network that will put together all this kind of expertise. And so what we have done so far in the working group, we have first of all trying to elaborate a vision. So there will, we asked ourselves if and how the world will change after the pandemic, but also in which scale and at which time, because of course now we are in the emergency, but sorry, I put, but how long it will take to for the world to adapt to what this pandemic and this emergency has created. So who will drive the change? Will the change be accepted? And then we try to design the roadmap structures, and Gloria will speak about that. So how it has affected and will affect the barriers, the need, the science and technology, and moreover, which sector should give a hand in building the full vision. There will be the public sector, of course. The healthcare management in many countries will depends on public funding. There will be the private sector, the role also of the community, because at the end of the day, it will be medical doctor, the patient association. So they will provide specific input. So our roadmap will try to put together all these aspects. And of course, we have to implement it. So this is also my presentation, a call for collaboration, a call for understanding that the roadmap is the creation of a vision in an holistic matter, and that all expertise, all ideas can and will be put together, will be meshed together in order to create a real vision for the future. So now a bit of more precision about science and technology. I will leave the floor to Lucia and then to Gloria. Please, Lucia.
Hi, thank you, Carlo. So good morning and good afternoon to everyone. Let me thank Zina for the opportunity to be here and to be involved in the roadmap working group. Laura, you can change the slide. Yes, the next one. So maybe you are not responsible for the situation you are in, but you are going to be responsible if you don't do anything to change it. So having this Martin Luther King quote in mind, we started to talk within the roadmap working group about the nano-enabled solutions we may identified during this month facing the pandemic time. Laura, you can change the slide. And for sure, what we have been discussing is the opportunity for rethinking science. And rethinking science will be closely related to the funding systems and the problems we had to face during the pandemic. Yeah, you can to the next one. So one of our goals within the roadmap working group is to bring the needs we will identify to the table of research councils and government agencies. Laura, please go to the next one. And so we will have 3 phases. The first one will be the mapping inside the AMPT, mapping the needs we can identify related to funding systems for rethinking science. The second phase will be the mapping in the academic sectors and research institutes at the global scale. And the third one will be to have milestones for the engagement of funding agencies at the global scale on the needs for actions. And in particular related to the need, as said before by Professor Falko, related to the needs of more collaborations, even outside of the list of funded of countries for certain funding agencies. And with that, I mean, thank you very much. I will leave the floor to Gloria since we are running out of time.
Thanks a lot, Lucia, and thanks also to Carlo for the work that we have done together for the roadmap creation. And thanks, Zina, for this opportunity to participate to this big project. So, Laura, you can go next. So, practically speaking, what will we do in this network? So, as a roadmap creator, we designed 4 practical phases. And the first one will deal with the mapping inside of AMPT of all the possibility that everyone can bring as a contribution to this network. So here you can see there are 4 points in this first phase. The first one is the map of need. So we need to have a map of business, companies, and social need. So what is needed from the business? What the company needs to fulfill this challenge brought from the pandemic? Second point is the possibility that AMPT contributors can bring to this challenge. So what each of us is doing to solve this pandemic problem, which is the contribution that each of us can bring. And then there is another group that will do a mapping of the knowledge. So there are a lot of work already published in literature that can be useful in order to fulfill some social challenges. And there is a group that is dedicated to look what is going on, what is the state of art of the technology that can be used in order to address the pandemic challenges. And then we need also strategic partners, because all of us is working, but in order to bring tangible contribution to this social challenge that was brought from COVID-19. So what we need is to have a partnership to bring a product in the market. You can go next, Laura. So at the end of this first phase, there is the second phase. So the roadmap working group will revise all the 4 points that I mentioned, and we will go in the next phase. We will create cluster and design activities in order to reach some objective for some product and in order to address some social needs. So the first point here you can see is the creation of the cluster depending on the needs and arrange the activity with the technologists and companies. So each cluster will embed the developer and the industry that will develop the product, possibly. If there is not this possibility, then this will be taken in the next phase. Then the second point is the interaction with the map of knowledge. So the map of knowledge will be integrated in the cluster in order to help the cluster in fulfilling the objective that was aimed to. And then the third point is based on common threads mapped, try to connect with the AHS group and try to face the public policy in order to have the right of development facing the guideline that are the one given from for instance, the European Union or US, so the regulatory agency, because we need to produce product that can be standardized and be idoneous to be on the market for the given purpose. And then there is the first point that is maybe one of the most tricky one, because we need to identify social thread that might be an obstacle toward the development of certain product. So this second phase will deal mainly with cluster creation, activity, identify the trends and give the right development facing the European or the national regulation. You can go next, Laura. Then there is the third phase. So as soon as we have clusters that are working toward the resolution of a certain problem, they will create some value. So every value that is created in each cluster needs to be developed in a certain timeline, so in the right way. We need to identify the roadblock of the development, and then we need to bring this idea, with this project, to the market. So here you see that there are other 4 points. So the first one, each cluster needs to define timeline for the development. And this development needs to be facilitated from also the other working group in the AMPT. Then as a second point, the industrialization working group needs to work together with cluster in order to identify, in case there were not present before, industries that can support industrialization of certain product. And then we need to also discriminate which product needs to be supported and which one is not as promising as expected. And the last one, we need to elaborate business model for the technologies in order to be industrialized and help also the return of the investment. Then as soon as the first phase is ended, we need to go on the market. So you can go next. And this is the last phase prior go to the market uptake. We need to certificate the product facing to all the statement that that AHS group and the standardization will bring. And the group of partnership and engagement needs to connect with strategic partners in order to assess the marketing taking. So we need to bring the product to the end, so to the user, in order to be really industrialized. And then with this in mind, we can also design some other modification of the product that are launched in the market. But the goal is here. So we need to address some social and market needs with the IMPT work.
So I think that Gloria finished. I think that we have been a bit long, Laura, so please do not hesitate to send questions via chat, so we will answer questions via the chat. And also, please, if you are interested, I saw in the chat that someone asked already to be part of the working group. So please do not hesitate to contact us, because the roadmap is an essential part of the activity of IMPT, and so we are waiting for you.
Okay, thank you, Carlo, thank you, Gloria, thank you, Chia, for your presentation. I hope everybody will join your working group after your presentation. So we're running a bit late, so we'll skip the question right now, as Carlo said. And now we will have a short 5 minutes mental break. If Gloria and Lucia and Carlo, please, you can turn off your video and mute yourself. Okay, so welcome again, everyone, to the Vision Accelerator event. We are ready for the next session. So for everyone who has just joined, welcome. Good morning or good afternoon, whenever you are. So our next session will be another presentation from one of our working group, Applied Public Health EHS. Gregory Nichols will be speaking from BP Nichols and Company from the US, and Kazi Tasneem from Vanderbilt University from the US too. So Greg, if you could please unmute yourself and turn on your video. Hi, Greg.
Hey, good morning, Laura.
Hi, good morning. I guess the floor is yours right now.
All right. Well, thank you very much. Well, good morning, everybody, and thanks for joining us today. And so, as Laura said, my name is Gregory Nichols. I am the president and owner of GP Nichols and Company. We're a consulting firm based in Knoxville, Tennessee. And we actually look at the issue of how emerging technologies overlap with public health solutions. And so this has actually been an interest of mine for a very long time. And we're going to talk a little bit more about how my expertise is being utilized in this and within AMPT and then the team that we put together to kind of facilitate some more discussion around these issues. So if you go to the next slide, please, Laura. All right, thank you. So this is the mission of the working group, and let me tell you a little bit more about how we got here and what we are doing. So as I mentioned, my background is in public health, and for many years now, I have focused on how we utilize technology and advanced material solutions more to improve public health. And so Zina and I have worked together for years. We've known each other. We've talked about how we can implement more of advanced material solutions into public health and what that would require. And so unfortunately, we were brought together in this time of crisis, but this has actually been a great way to kind of merge these two communities together. And so I was asked to stand up a working group looking at public health issues, how we identify these challenges, and how we can take these material solutions and integrate them into addressing some of these needs. And so, this is the formal mission of the working group, but basically what we are facilitators, right? We are looking at these public health challenges, and we're working with researchers and the academic and industry communities of advanced materials and helping them identify how their solutions can meet some of these challenges. So let's go to the next slide, Laura. All right, thank you. I think we have a little bit of a lag, so if I'm silent, I'm just waiting for the slides to move. So we've actually done quite a bit in the past few months. So we started meeting in early June. There's about 8 of us or so, and we meet every 2 weeks. And we have, I think, amassed a really great group of people. These are some of the leading experts in the US and the world in terms of regulatory testing and commercialization of advanced materials. And we have developed a strategy and some near-term goals that we want to achieve within the next few months. And those have been posted to our website. So if you haven't already looked, you can go to the AMPT website. You can look at the Applied Public Health and Environmental Health and Safety Working Group site, and we've got the goals and the strategy there. So a few things that we've done so far. We recognize that it's very important to get our message out there. The public health and advanced materials communities are very much focused on applications, but also there's a huge research and development component, right? So a lot of what we're trying to do is to bring those two communities together. And so we're doing this through a series of, getting work products out there, which we'll talk about in a second, but also doing a lot of outreach, right? Getting webinars and other sorts of presentations together so people can really understand what we're trying to do. So one of those things that we've done is we have submitted an abstract to the Nano Toxicology specialty section of the Society of Toxicology. This is for the graduate seminar series. And so this is a way for people who are kind of coming into the field of advanced materials to understand a little bit about what it takes to actually bring your work, into the real world. And so through a lot of the conversations that have happened since we set up the working group and before, we've actually identified 2 different challenges. And these were brought to us by a lot of researchers in industry and academia, and then we've identified these as well in public health. So 2 of the big challenges right now is one, that component of identifying the regulatory testing that's needed to commercialize a product. And we'll talk a little bit more about that in a second, why that's a big challenge. The second thing that we're getting to is understanding once you have a product, right, how do you actually know whether or not it's effective in fighting, for right now, the SARS-CoV-2 virus, right? And so that's very challenging, as you can imagine, trying to coordinate a network of labs and other sorts of facilities where you can actually take your product and you can test it to see if it actually works. So that's a challenge that we're working on. But for right now, we've got a lot of focus on identifying the regulatory testing that's needed to get these materials out into the real world in short order. And so I'm going to turn it over to the lead of that project here in a second, Kazi Tasneem from Vanderbilt. She's done an amazing job leading this effort. And so I'm going to give her a couple of minutes to talk about the progress we've made so far.
Okay, thank you, Greg. Hello, everyone. This is Kazi. I'm from Vanderbilt University. With my background in chemical engineering and toxicology, I find it really rewarding to be able to work with Applied Public Health and ESH working group within AMP. Thanks to Zina, thanks to Greg. As Greg mentioned earlier, it's critical to close the scientific and the regulatory gaps in order to expedite the application of advanced material during the health crisis. So in this regard, I have been working on developing a regulatory testing matrix for conducting urgent toxicological testing for advanced material solution. And I can give you some quick examples. Right now, we are looking into US regulatory network, and for example, antimicrobial disinfectants are regulated by EPA, Environmental Protection Agency. Products like disinfectant devices for healthcare, those are regulated by Food and Drug Administration. And we all know about the respirators. So those N95 respirators, surgical mask, and the face mask, those are regulated by CDC, National Institute for Occupational Safety and Health. So all these products comes with lots of regulatory requirement from the regulatory bodies. And if we think about incorporating advanced material into those materials, as for example, silver nanoparticle or the carbon nanotubes, there are separate regulatory requirements too. So what we are trying to do right now is we are working on developing a comprehensive resource for regulatory testing requirements so that we can speed up the implementation of advanced material solution. And next, we will plan to extend our analysis for international standards for toxicology testing. So with this, I can say, this concludes my small section of the presentation. I'll now hand this over to Greg to talk about our future goals. Thank you.
Hey, thanks, Kazi, very much for the update. And Kazi has really been my right-hand person in the working group and has done a lot of the work pulling this together, so appreciate her help. So Laura, can you go to the next slide, please? And so when the slide pulls up, there we go. We're going to talk about some of the future goals and plans that we have for the working group. So as Kazi just described, we've got a pretty big project underway with looking at this regulatory testing matrix and how we can help facilitate some of the commercialization. But we've got a few other things that we want to tackle. So the next big thing is looking at how do we provide access to people who want to test their product efficacy, right? So obviously you need access to live virus to see if your product, whether it's some sort of coating or whether it's some sort of disinfectant, whether it works. And so it's really difficult to put some live virus in a FedEx box and ship it right now. So we're looking for ways that we can create a network where people can send their products to labs or maybe already working with the virus, and how we can kind of facilitate some of that. And two other things I'm going to focus on. We've got this great gathering of experts. And so how do we capitalize more on their expertise and assist people? And then finally, the big thing, especially one of the reasons that I got involved, is how do we take these lessons that we've learned from this group and apply that more to the public health community? So Laura, next slide, please. All right, and so just to wrap this up before we get to some time for questions, we'll talk about two different needs that we have here in the working group. So one, it's more internal to AMPT. So we're looking for ways that we can establish better relationships and foster that growth with the other working groups, right? This is not something that just involves us. As some of the other presenters have mentioned, when we talk about commercialization, we talk about the roadmap, we talk about partnerships later on. It's really how do all these different components work together? So how does the Applied Public Health and EH&S working group match the needs of partnerships and the roadmap and so forth? So we're looking for ways that we can communicate better about how we work together. And so for the general audience, for all of you who aren't necessarily involved in AMP, but have an interest in public health or advanced materials, we're looking for a few different things. So if you have any type of major health issue that you have identified, that you think there's a need that advanced materials may be able to meet, let us know. We want to know about that. We want to know what are some of the challenges that you're having a hard time overcoming. If you're working on a COVID-19 related grants or other type of project and you realize you need some environmental health and safety expertise, reach out to us. We're definitely open to partnerships. We are here to help you. If you are just looking for advice as to how advanced materials can improve the health of your facility or your community, again, we have that expertise. We are here to provide some guidance. And then if you have expertise in environmental health and safety or public health, or you're a student and you're looking for some sort of experience to contribute to this global community, reach out to us. You can reach out to me, you can reach out to Zina, but we're happy to kind of look at what you think you can offer and find a place for you. So that's really everything in a nutshell. I know it's a lot, but I want to have some time for questions and answers, and I'm willing to do that now. So we'll go ahead and open it up to any questions.
Okay, thank you, Greg. Thank you, Greg and Kazi, for your presentation. So I guess we're out of time now, but we have questions in our chat. So please, Greg and Kazi, check it out. So you maybe can contact Jay directly and talk with him, because he's really interested in working group. So I think we're ready for our next session. So thank you again, Greg and Kazi. If you can please turn off your video and mute yourself. So our next session will be a panel. Advanced material enable commercial solutions, product for a pandemic world. Ray Gibbs from UK, Russ Andy from Cardea Bio from US, moderated by Adrian Nixon from Nixon Journal from UK. So if Ray, Ross, and Adrian, please can unmute yourself and turn on your video so you can start your panel.
Hello, Laura. Can you hear me and see me?
Hi. Yeah, I can hear you loud and clear. Hi, Adrian.
Nice to see you, and
nice
well done so far for organizing these virtual conferences. It's all new to everybody. Well done.
Thank you. Thank you. So, and Ray, you here too?
Yes, I'm here. Good morning, good afternoon, good evening.
Okay, so I'll leave you the floor to you.
Thank you very much. Hello, everybody. Lots of familiar names in the audience too, so nice to see such a high-powered audience. We got two people to talk to today in the next sort of 25-30 minutes. You'll probably be familiar with both of them, actually. And first one is Ray Gibbs. He's commercialization director of The Geek, as well as a non-exec director and chairman of Planetech, and based in the UK. We've also got Ross Bundy. Hello, Ross. Can we just check your video works?
Yeah, I'm having a little bit of lag, so hopefully it's on, but I see it on from my side, so.
Brilliant. That's nice and sharp. The lag seems to work okay for me. That's fine. And Ross is the co-founder and chief production officer at Cardea Bio, Incorporated in San Diego, California. Mm-hmm. So it's the afternoon for me and Ray, and it's the morning for Ross.
Just got up and drinking coffee.
So just to give a little bit more of an introduction than I have, can I invite Ray to say something about himself first, and then we'll move on to Ross. So Ray, over to you. A quick introduction.
Very quickly, Adrian, I've been involved in the graphene space since 2010 in a variety of different guises. More recently, and really focused on supply chain, which is crucial to commercialization of graphene, But actually recently I've been spending, as you know, quite a lot of time in Manchester helping the commercialization of graphene related products into a company to be set up very soon called Manchester Graphene Company. And that's really an exciting process where we're looking for increasing prosperity, business jobs and everything else in the greater Manchester area. And my other job, which is suddenly taken off quite a lot, has been involved with graphene products from Planatech, CVD, chemical vapor deposition products. But more recently, we've entered into the realms of the graphene masks, which we'll talk about in a bit.
Great, thank you very much. Ross, over to you.
Hi, no, I'm Ross Bundy, and me and my co-founder co-founded Cardea about almost 7 years ago with an idea to kind of commercialize one of these carbon-based electronic sensors that seen a lot in academia but haven't really made it out into commercial world. My background, I am not a scientist. I've spent 2 decades in supply chain in several different industries. And so we've really been keeping our heads down for a long time and just focusing on, can we actually make a carbon-based electronic system? And so it's been a long road, but we're here. As a business, we actually partner with biotech companies who want to enable a sensing style product. We have several different product development efforts in the works right now in a wide variety of industries. COVID is a big part of what we do. But my role was figuring out how do we actually make a graphene-based electronic system. And today we've been able to get graphene working in a commercial foundry with commercial packaging. We're generally doing multi-wafer batches, running hundreds of experiments per week now. So it's been a difficult, interesting road, but now we're here and we're scaling and it's working really well. So.
Yeah, and you've been busy. We'll come to that in a minute.
Very, very busy, yes. Yeah.
Just a quick bit about me. Adrian Nixon, I am a scientist, originally an industrial chemist. I'm the editor of the Nixon Journal. So this is a journal that specializes in graphene and 2D materials. And we keep a watch on all the activity, technical and commercial. So we read a lot of the research papers and we look at a lot of the commercial activity and translate that into plain English for decision makers, industry people worldwide. And we produce an issue every month. We're currently into volume 4, so we've been going for 4 years. And I can tell you that Ross and Ray come up on our radar with increasing frequency. The pace of change that's going on in the graphene world is astonishing from our point of view. And Ray and Ross are right at the heart of stuff that's going on with COVID as well. So perhaps I could invite you, Ross, to start off with and just tell us a little bit, before we get into the companies, why are you involved in the Advanced Material Pandemic Task Force, and what's in it for you? How do you see the AMPT sort of helping you take advanced material solutions and products into the market?
Yeah, so we haven't really spent a lot of our time engaging too much of the graphene community, mostly because our customers are biotech companies, and so we've mostly been focused on the biotech world. That being said, though, you know, we've crossed enough chasms now that it's more or less time for us to really start engaging with also with the graphene community a little more now that we've got a few things covered for the company. And in particular, though, this pandemic really highlights a lot of the vision that we've been pushing for a long time with our company, which is that there's really a disconnect in the biological world where you can't really merge the best of, say, the digital networks that we've established and engineered for the last several decades and the biological world. We keep them separate because biology is so complex to work with. And most of the instrumentation that is used puts biology in a very narrow, defined box, and it looks in on it and it looks at one thing at a time. And in many ways, this is a weakness of the existing methodology that we do things in life science. And you're seeing that today because the diagnostics that we use today to detect COVID, quite frankly, COVID is a little bit unique as a virus in that it hits where every form of diagnostic methodology that we use today is weak against the way COVID actually works. And so as a result, we just haven't been able to get our arms around the pandemic. And so a lot of what we've been doing is what's at the core of what we do, what we call this biology gated transistor, is a way to directly integrate biology such as DNA and proteins and cells into electronic systems and taking out a lot of the complexity of optics and all these other things and directly getting the best of both worlds. And we can do that because graphene is uniquely the only material ever that allows for both biocompatibility and high conductivity at the same time. And so that's really what we do. It's a difficult thing for a lot of the biotech people to understand when we start talking a lot about advanced materials and physics and that kind of thing. But they're starting to come around. But to that effect, we now are saying, you know, this is what we do. Like this pandemic, this is exactly the reason we started this company, was to get a quicker, more timely, effective way of understanding what's going on with our biology. So when it, you know, and we are an advanced materials company. You know, graphene is at the core of everything that we do. So, so it just made sense for us to start reaching out, be a part of this group, be a part of this network, and say, you know, this is what we're doing. We're building it. We've already gone a long ways in the last several years. So, so we wanted to kind of be out there and have people kind of see what we're doing, see what they can help bring to the things that we're trying to accomplish, and hopefully get some of the things that I'll be able to talk a little more about that we're doing out to market, and really make a dent in this.
Brilliant, thank you. That's great. We'll unpack a little bit more of that in a few minutes. Let's just switch over to Ray. Ray, why are you involved in the Advanced Material Pandemic Taskforce as well? What's your interest?
Well, it's multifaceted, really. First of all, I've known Zina for a while. She's enthusiastic and gets things done. And I think what that is proven is that is exactly what she's done. She's got things done and we're all together. What I like about this is that it brings the world together. We are global. This pandemic is global, hence the name. And I think from that perspective, it's bringing people together with a common goal and a common purpose for which we're all going to learn. Much more so than, sadly, it's not a political comment, than the respective governments around the world. So I've also seen a lot, particularly in the UK, where companies just stopped adopting some of the more difficult processes, and they got together and they built respirators and ventilators and various other PPE equipment in days as opposed to years. And for me, that was fantastic. And it just shows what collaborations can be achieved and how quickly they can be done with a view to just sort of driving a coach and horses through some of the more difficult processes that we have to cope with. So for me, that was one aspect of the whole thing. And I'm also being involved in having a mask, a graphene mask, through the planar tech thing. I started seeing Me Too stuff out there, which was frankly not regulated, and I just think that's just not clever, not good, and it creates distrust.
Yeah, interesting. So there's a number of different facets here. We've got Ross sort of saying on one side of things that the work he's getting involved with now, particularly with the virus, is having a similar effect to what you're saying as well, Ray. It's sort of cutting across lots of different silos. So we, as experts, we tend to sort of focus on one particular area. This is cutting across geographically, functionally, legally as well. And there isn't anything around at the moment that stitches it all together. So this seems to be where Zina's sort of heading. And I quite agree with you, Ray. Zina is a sort of an irresistible force in organizing these things and bringing us together. Probably why a lot of us all seem familiar to one another. Brilliant, thank you. So moving on, let's think about just what in the context of the pandemic, could each of you tell us about what your organizations have been developing and delivering? And Ray, if we stay with you for a minute, could you tell us a bit more about what Planetech's been doing?
Yeah, sure. And in fact, we got basically Planetech is run by a guy called Patrick Franz out of the Far East in Asia. We've had a number of people that we know in Taiwan and China, and for many, many months. And I go back before Christmas, by the way. They were saying, certainly the Taiwanese, that they'd gone into lockdown, and we knew that there was a problem. We didn't know what it was, but we knew there was something that was going on inside PRC that was being kept under wraps, I guess. So we decided that we would build a mask and an early stage get on and deliver it. And we use graphene primarily to do a number of things, one of which is to create a coating on the mask which became effectively anti-static. One of the properties of graphene, among many things, is that, and it does have a barrier property too, and that's created a very workable, sensible, comfortable mask. And for me, that just demonstrates, and it was very interesting to see this being looked at in the Middle East, by the way, when somebody picked it up, and I can't mention the name because it's quite high up in the UAE. It actually said, look, this is a real world life aspect of an everyday product, graphene doing something in every day. And now you can see that, you just pull this up, thank you. You've got the key features on here, which basically is it's antibacterial, it is anti-static, and it does actually cope with multiple washing. In fact, it's not on here, but it does actually go through an autoclave before and after the testing processes. So 120 degrees, 15 minutes, 15 PSI. So it's capable of handling sort of autoclave actions as well. And it's been very useful. Now, the point about the mask is it's self-assessed. EN 14683 is self-assessed. And then you've got effectively 3 layers, of which we'll put them together, and are built and put together in Thailand, high quality, and we're getting a lot of traction around the world. I think there's a couple of other slides going forward if you want to push on. Laura. Hello, can you move a slide? Thank you. This is a busy slide, but it basically is trying to demonstrate what the other masks in the world are all about. And really it does demonstrate that there is a wide variety, and there isn't an actual matrix that pulls all this together so that the buyer just doesn't know what they're getting. And we're seeing a lot of masks that are bought and then thrown away, and they're now emerging in the sea, they're now emerging in landfill, and with potentially hazardous results. So these things are difficult, and that's an instantaneous reaction to something that we did to try and keep people safe. So really, that's what we're doing, and we can brand this product. It's capable of being sold. We've got actually sales in excess of 160, 170,000 of these to date so far, from a standing start of about a month and a half ago.
Wow, you don't hang about, do you?
No, try not to. And the thing with self-certification on EN 14683 is you have to go through these, and there is a range of different standards for those that are anal about that. They can pick it up. It's EN 14683-2005, British Standard Institute, range of bacterial efficiencies. You've got breathing resistance, you've got splash resistance, and the different masks give you different protections as you go forward. So we've had those tested. We've had them tested in Korea. We've had them tested in Thailand, and effectively they're great. Interestingly enough, some people say that we want the testing done from an EU perspective in the European Union. Such is the demand for testing that the backlog is at least 2 to 3 months in terms of getting testing done, which is quite a challenge.
Yes, it is. Yeah. Although your masks seem to be getting out, I see in the chat window already that Jay is saying that he has one and they're great. So your masks are...
And they are CE marked. It is self-certified, and that actually in itself means that you have to rely on the certification of the certifier, but that person is at risk if they do not adhere to the certification tests.
Yeah, that's a very good point. Particularly with the pressure on everybody with the pandemic at the moment, there'll be a lot of stuff being hurried to market. And I get the impression that you're trying to do things in a responsible, auditable way.
Well, we see things like, oh, we're a virus buster, and we're a virus killer, and I'm thinking, oh, good grief, here we go.
I've seen that too.
Yeah, and it's just not clever, and it leads to the pandemic creates panic, and then people buy because they think it's going to create that safety when it actually doesn't. And that's really hard and difficult, and the short-term profiteering is not clever.
Yeah, yeah. One of the other details about your mask I noticed was, did you say it was washable and reusable?
Yes, it is. It's been specifically the ink that we use to coat the polyester film with has actually been specially developed so that it can be bent and manipulated, which is a challenge in itself, but actually can be used time and time again. And the antibacterial properties retain 99.96% properties for at least 10 washes, and they've gone for an autoclave at the same time. So that's a real benefit of graphene in a real everyday world product.
Yeah, Ray, I could talk to you for hours about this.
I know, but we'll carry on.
We have a tight amount of time, and both you and I know how well Zina manages time. So I'm assuming we're going to go over about 5 minutes from our original one, which gives us time to talk to Ross about, could you tell us a little bit more about what you've been doing, Ross, and the products you've been developing?
Yeah, sure. So we have, I mentioned before, what we call this biology gated transistor. So this idea that you can build a semiconductor style transistor, but actually directly incorporate things like DNA or proteins into the circuitry, and now that becomes part of the circuit itself. What that does is it allows you to get all the best things of the electronics world and the biology world. Electronics meaning, you know, lower data and signal processing and miniaturization and low cost, but then all the complexity that comes with biology. And the complexity is really, really important to understand. So I read the news a lot. I follow a lot of what's going on in the pandemic, and we all follow the test cases and the number of cases that come out there. And so there's a couple things that get into the scientific weeds about the way the tests work that actually tell you that we don't really have a good handle on any of the testing that's going on. The sensitivity of the PCR test, that's kind of the gold standard we use, is roughly 80%. In diagnostics terms, that means that 80% means 4 out of 5 are true yeses. So that means 1 out of 5 are not really true yeses. That's not great when we're doing millions and millions and millions of tests every single day. On top of that, there's a window that the PCR test, which is the gold standard, is only effective. It's usually about 4 to 14 days, but the virus starts dropping off after that. And so then the test doesn't become very effective unless you get reinfected again. Now people are looking at things like antibody tests, but antibody tests look at your immune response to the test, and nobody really understands what our bodies do to the immune response. The research is very, very new on this, and some people are saying maybe it drops off after 8 weeks, the antibody tests aren't effective, maybe it's this, maybe it's that. And so part of the problem is there's a real diagnostic question that none of our actual testing methodologies can answer. And the question is, should I go outside today? Should I go into the public? Am I going to infect other people, or should I stay home and quarantine? And the reality is we're in these lockdowns and these quarantines because we don't know. And the tests can't really tell us those answers. I'll give you an example. Someone I know in my very close personal family has tested positive for COVID. And she has tested positive now 3 times on the PCR test, and yet her spouse has not tested positive. They're together every single day. What does that mean? She has no symptoms. He has no symptoms. Is he sick? Is she sick? What does this even mean? There's no way to really understand this. So, okay, she keeps testing positive. They need to stay home, but okay, but nobody's getting sick. So how do you deal with that? And how do you understand all that? I'm sorry?
I think somebody had the mic open.
Oh yeah, so how do you understand this type of thing? And none of the tests really can give you these answers, particularly when a lot of the tests, because they have to be run in these centralized labs, they also take a long time to get results. And so maybe someone's sick and they're out infecting other people, and oh, now it turns out I'm sick. Now I have to figure out everyone I spoke to or was around for the last 6 days, and it's a nightmare to really handle. So a lot of what we're trying to do is building a system that utilizes some of the biology that people know to look at the DNA, to look at the proteins, but put it all on an individual chip. One of the other main limitations in life science is that biology is really, really complicated. And as a result, we've created these artificial silos of genomics and proteomics and cell biology and all these other things. But that only exists because that's how we as humans try to comprehend all the complexity of biology. But life science doesn't work that way. DNA and proteins and cells and viruses, they all interact with each other all the time. And so really, one of the key things is you need to be able to look at all of the different components to get a complete picture. The virus is there, the viral RNA is there. but my body's not reacting. Am I sick? Maybe it's dead. Maybe it's just there, but it's dead. So how do I understand what it is I'm trying to do? So we do a couple of things. One of the things we've been spending the last few years on is something that you can see in our publications, what we call the CRISPR chip. CRISPR is a biological defense mechanism of bacteria to defend itself against viruses. It searches through whole natural genomes. If it finds something it doesn't like, it cuts it. Our chief science officer realized that that search function it put down on our chip enables effectively a DNA detection device that looks at natural DNA without any of the complexity of amplification, which is what is the PCR methodology. And you can find, and if you tune it to a specific sequence you want to look for, such as the virus's RNA, then you can detect it by just putting samples on a chip. And we've done this. We can see viral loads, we can see specific RNA of the viruses, that kind of thing. What's really important is that that's just one of the transistors on the chip. I can put lots of transistors on a chip and also look at, is my body reacting? The biomarkers of being sick, the biomarkers of the antibody response, markers for flu. Maybe I'm sick, but I have flu, not COVID. Those are different things. And put all that together in a tool that can effectively be run on your cell phone because our electronics are actually vastly simpler than our cell phones are today. So we've done a lot of this work. We've shown that we can detect these types of things, we've done it in clinical samples. We have access to clinical samples for COVID through some of the biotech connections that we have. And so when we look at what we'd want to roll out, the current tests are pretty good for hospitals and clinics for what they need. And so a lot of what we've been focusing on is more occupational health style methodologies. You know, if a first responder, such as a fireman, goes out in the field to do his job, does he get infected by people? Can he go out again? Is he going to infect more people? That's a big issue that all first responder agencies really need. You know, medical, you know, the medical providers in hospitals, they're getting sick all the time. Should they go home and quarantine? They need to be able to check immediately and see, can I go in? Can I expose myself to other people and not get them sick and do my job? Or should I go home and self-quarantine? So that's been our approach. It is technically possible and it is technically feasible, and we have a lot of the supply chain and everything figured out. Unfortunately, it is a big, big vision. So, and our business model is mostly through partnering with large companies. So we're now starting to talk to a few companies that could help kind of take this vision to market. But it's a little bit bigger and beyond the resources that we have today for us to actually materialize that vision. But that's a big part of what we do. Again, we've been producing batches of 2,000 to 9,000 chips at a time for the last several years now.
Wow.
So we're starting to get going. And really starting to ramp up around this, but as much as I love the promise of what we can do and make it so that at every one of your businesses, you can have that screen right there at the front door and see if you should come in today, which is kind of the thing we want to do. Unfortunately, it does take some time to actually build enough of the supply chain and consistency in order for that to come to market. A lot of resources. So.
I'm just getting a quick nod, Ross.
Sure.
3 minutes to pull everything together, but to summarize this so far, from what you've told me, you're taking what you're making these really sensitive sensors based on graphene, and then you're using CRISPR technology and other technologies. So basically, you're making it like a Swiss Army knife sensor where you can have lots of different tests all in one chip, and you can detect COVID and do it very quickly.
Yes, that's pretty much it. The main thing is we actually cut out most of the typical methodologies we use to detect things. You know, most nucleic acid detection uses a lot of heat and other things that would destroy proteins, so you can't mix those two together. We don't need to do that with the way our technology works, so we can actually put all these different types of omics side by side and do a multi-omics approach. We're already incorporating machine learning into what we do to approach detection from multiple different avenues of proteomics, genomics, virology, and put a more comprehensive picture together about what is really going on in your body. And that happens within the span of 15 to 20 minutes. You know, the detection is actually pretty quick because it's very small samples, and it really depends on the biology. But yeah, the transistor is open, and then we tune it by putting certain biology down to make it specific to one thing or another.
Wow, really impressive. Again, I could talk to you for hours about this. This is fascinating. Audience, we're going to hear a lot more about Ross and Kari in the future because I've seen some of the stuff they're working on. It's really amazing. Ross, I'm going to have to close things down a little bit. I just want one final question to both of you. Over to you, Ray. is there any help you need from AMPT to do more? Any help from Zina and the gang, or governments, things like that?
I think for us, we've concentrated on Europe and Asia to begin with on some of the things we were doing on our face masks. There's a question in there about whether or not we can coat cotton. The answer is yes, we can. And that's the next stage on PPE. But for me, something with help would be, how do we meander through all of the nuances in the American system? Where do we go? Nelson Labs? How do we go about doing the NEOSH stuff as well? And that would be something that we would want to look at and go further forward. And I've got a couple of questions on there that would help.
Yeah, yeah, sounds good. And Ross, same question to you. Is there anything AMPT can do to help you?
Yeah, I would say the two things. We have an interesting time with government agencies, and what we're talking about doing is certainly possible, but it takes a lot of money to scale a production and really produce something that an average user can utilize effectively. And so we've been talking to government agencies. They feel that they're a little ambivalent in different ways. So as much as the message can be kind of spread around through different government agencies to help us kind of scale this, that's a big effort for us. And the other side is, I know that there are other companies and academics who are working on different things in proof of concept. As far as I'm concerned, we've been doing a lot of the proof of concept for biosensors like this since we started the company. We already had it in place. My co-founder was doing this before, maybe 10, 15 years ago. The chips work. We're building a partnering model still to be able to work with academics to be able to test things and take things to another level. So we're still a little bit challenged in terms of working with people, but we're building a better system for that. But reach out to us if you want to actually do something with a sensor. I mean, like I said, I produce thousands every single couple of weeks even. If you're interested in doing different things with it, reach out and we'll find a way to make it work together and develop better research. So rather than just rebuilding what we already did, try to take it to the next level, build on top of it, and take it to the next level.
Brilliant. That's excellent. Ray, Ross, smashing. Thank you very much. We've covered a massive amount of area in a very tight amount of time. Zina and Laura, over to you. It looks like both Ross and Ray are sort of showing us that the world's changing with the way COVID's hitting, the way all our lives are changing, and getting networked together and communicating in different, fast, rapid ways seems to be the way forward. So Zina, your vision seems to be pretty much on target. Over to you guys.
Oh, thank you guys. Your presentation was excellent. The chat was on fire for you. So I invite you to check it out. Try to answer as much people as possible because they were really interested in what you were saying. We can go to the next session, and it will be another working group, the map of needs, with Manolo Almagro from Q Division from US and Ben Gauthier from Q Division from US too. So Manolo and Ben, if you can please unmute yourself and turn on your screen so you can start talking about your working group, what you have done so far, and what is the purpose of the map of need.
Great, thank you so much. Can you switch the slide, please?
And I leave the floor to you.
Thank you very much. Hi, I'm Manolo Almagro. I'm in Austin, Texas, managing partner for Q Division. We have been working on our industry and sector classification as it relates to how we are looking across the different industries and the applications for advanced materials. So from our perspective, these are the areas of focus for businesses that we work with, and we've created subcategories in them so that as we work through each one of the opportunities that we see, we can categorize them quickly and place them in areas and then share that back with the group. I think our biggest challenge as we work with such a large group of companies and opportunities with the different types of technologies is where we can place them within the different sectors. So we use this specific type of, we wouldn't call it a map of needs, but it's more of an industry and sector classification as it relates to the type of industries that we're focusing on. So in this case, you know, we would look at consumer commerce, and you know, that's basically everything that has to do with exchange of money and services. So retail, hospitality, all the way through to public services, which is more on, like, let's say, smart cities, infrastructure and things like that.
Yeah, so, you know, when we talk about like a map of needs, that's kind of going through, it's not about like masks or the great work for masks that people have been doing here, and the same thing for like testing. These are smaller ones to be able to see that you may not like know exist. And so to start that, like Manolo said, we have to have this categorization. At Q Division, we are about really, for our clients are mostly retailers and brands, and we try to uncover the same way that we're the properties that a lot of the advanced materials that you guys are working on. What we do is we always look at new technology. So like before COVID, it was a lot of like startups and different kinds of things to apply. And so this kind of categorization allows us to kind of see, it's like, these are the different parts where there are going to be different kinds of shifts that are happening. And you'll see that later on in a different one. But when we start taking a look at where the needs are, a lot of it has to do with consumer behavior, the behavior of people in general. So if we could move to the next slide. We do like a lot of different types of mapping to understand like the behaviors and experiences that people kind of have. So it's starting to see where there's going to be a change in how someone kind of is behaving out in the real world and where opportunities kind of lie. Now, an example of that kind of shift in a behavior might be things like using video conferencing, the fact that we're doing this as opposed to all getting together in some parts of the world to kind of meet. That's a behavior shift that's happening. And so like that exposes different types of behaviors in different types of industries as well.
Yeah, and so when we look at these behavior maps, this is when we go through a specific exercise with our types of clients. In the case, we'll use retail just because this is a retail experience about how someone orders pizza online. Now, it may seem like a very granular and mundane thing, but as we move through this, we also expose things and changes in behavior because of COVID, like why people don't want to touch surfaces anymore, or the fact that they want contactless transactions, and where the opportunities are for things like air filters or some sort of indicator that tells you if the packaging has been exposed to COVID and things like that. So as we move through each one of these behavioral analysis, we expose and present areas where we can say, hey, is there a technology that can help with this type of situation? So as Ben said, we don't necessarily go straight to a solution, say, oh, everyone should be wearing a mask, which is still a great idea. We are looking for those unexposed new areas of opportunity to apply advanced materials. Can you go to the next slide, please?
And that's where like this map starts to kind of come into shape, where you start to see shifts in different things. And this is going to expose opportunities, but there's a small, well, it's actually kind of big, it's like a disconnect that would end up happening with not just the properties of the materials themselves and how they could be utilized, but it's also like the trajectory of your research and where things are going, because we're not just looking for longer term things about like 5 years down the line. We're looking at things that are, we want to look at things that are near term. So it's understanding the trajectory, where things are going, how and what types of research that's kind of going on, and then map them to these shifts that are kind of happening to be able to expose that stuff. Because as we start going through, like we at Q Division start to like bucket things and for our clients as to like, is it a foundational technology, a disruptive technology, or like a radical one that needs to kind of be tested, but like just exposing different types of things where stuff could be used easily and just to latch on to the work that's already being done to see where you would be able to apply, and we could bring those solutions to our clients.
Yeah, and as we expose a lot of these opportunities and through this analysis, what you're going to see is we apply that to our client ecosystem. So on the right, you'll see just a bunch of logos of the different kinds of companies we're currently working with. Some are retail, some are grocery, some are sporting goods companies. And what happens is as we start looking across the industries, we find similar technologies that have solved similar types of challenges. And it allows us to basically inspire that solution into a new area. So as we look at these types of clients that we have, we look across the different type of industries that are looking to solve certain problems. What we'd like to do is start sharing what we find as opportunities, and then hopefully we can look toward the solutions that are being developed or have already been deployed and apply them on top of our client ecosystem. So that's how we'd like to start sharing out how we're seeing different behaviors change and then applying the technologies to the areas that we think are opportunities. And now we can take questions, if there are any.
Okay, thank you, Ben. Thank you, man. So we're running a little bit late. So if anyone can please write questions on chat for Ben and Manolo. Also, if someone wants to help them and join them in the working group map of needs, please join the chat and chat with them directly. So we will go directly to the 10-minute break. Thank you, Ben. Thank you, Manolo. Great presentation.
Yep, thank you.
Okay, guys, welcome again to Vision Accelerator event. So thank you for showing love for our regional chapters and more, because we're missing a lot of countries in the world. So we hope we will fill this gap as soon as possible. So let's start our next session. That will be another working group, the Library of Knowledge, that will be presented by Dr. Baig Al-Muhid by Vanderbilt University from UHAS. So Baig, can you please unmute yourself and turn on your video so you can start talking about your working group. Hi, Baig.
Hello, Laura. All right, so hello, everyone. Good morning, good afternoon, and good evening for my audience all over the world. Let me give you a little background about myself. I am Baig Al-Muhid. I have a PhD in civil engineering with specialization in computational material science from Vanderbilt University, where I'm currently a postdoctoral researcher. Throughout my graduate career, I worked with fiber-reinforced cement composites, especially graphene cement composite, both experimentally and computationally, from both nanoscale to macro scale. So this leads me to AMPT, as I believe my vision, passion, and knowledge can help AMPT's vision for using advanced materials to fight COVID-19 and future pandemics or the like. So the next step is to learn what really is AMPT's vision and what the vision of Library of Knowledge Working Group is. So next slide, Laura. Okay, so AMPT is, as Zina has mentioned, it is Advanced Material and Future Preparedness Task Force, a truly global task force coming together to achieve the same goal. AMPT has 10 working groups, of which Library of Knowledge, which I'm currently leading with 2 other members, is one of the working groups within AMPT. So the vision of Library of Knowledge is to create extensive knowledge database with easily searchable keywords for all audience interested in learning or knowledge sharing about the behavior of advanced materials that can protect against COVID-19 and future similar kind of pandemics. Under the Library of Knowledge, we have gathered more than 100 journal articles, grant proposals, industry or technology innovation informations. We divided the information in the Library of Knowledge in several categories, as you will see later, for easy navigation. If you notice the flowchart below, we are working on categorizing the information in nano coatings on materials, sensors, essential elements such as masks, goggles, PPEs, anti-fogging devices, air filters, antimicrobial and antiviral filtration devices, all of which have several subcategories. This method allows us to understand current research direction and which part of research are transferable to technology or industrial development right away, and which need a few months and which need a few more years into the future. So we are coming online with our first report about nanocoating on hard surfaces within a month. The report consists of 2D materials, ceramics, polymers, etc., with experimental and computational efforts such as nanoscale to mesoscale modeling, with physics-based models such as molecular dynamics and data-driven models such as machine learning. We are trying to give a holistic understanding of advanced materials in nanocoating. This is our report is going to be about. Now, under the flow chart, we have a category called nanocoating. If you look at the red rectangular box below, you can see that outline of the report on the right also. The question is why we are choosing nanocoating, why nanocoating is important, and why there's the word nano in it. What is the advantage of nanocoating? So without going into too much scientific details, I'll say that nanocoating on a material has two very impactful advantages. That is the geometry of the surface at nanoscale and water repellency. It can be synthetically made hydrophobic. That means the surface can be hydrophobic. That means it's water hitting. By modifying its nanostructure or nanogeometry, which is again geometry of the surface at the nanoscale. Now we can see the behavior in nature. As material scientists, sometimes we take inspiration from nature. We are all familiar with lotus leaf and a rose petal, right? When water falls on these leaves, they agglomerate to form water droplet and falls off the leaf. It doesn't stick to it. That's because of their nanostructure, of the nanostructure of the rose petal or lotus leaf. As you can see in the inset, the protrusion that's protruding from the surface of the rose petal or lotus leaf doesn't let water to spread on the surface. That's why they fall off. Now, if you want to know more about this, instead of Googling, please go to our website and find Library of Knowledge database. If the material surfaces are made to possess this behavior that helps to fight against COVID-19 or any such future pandemics, because the viral droplet that contains the virus might get rolled off or could be easily cleaned off by pressure washing, etc. Next slide, please. Okay. So lastly, we want to call to action to AMPT members, which we want to collaborate to modify and accelerate our map of needs based on our recommendation from the Library of Knowledge. I would also like to call upon our general audience to help us make the map of needs by understanding the needs of the healthcare industry. We want to make the medical devices or anti-fogging goggles better. Construction industry, which has a high potential to spread virus. Transportation industry, hotels, tourism, and banking industries, for example, card swapping, etc. And because of the coronavirus, we are all waiting indoor and ordering online. So packaging industry is a very it has a very high potential to spread the virus, because it seems that the virus lives longer on the porous surface rather than the metal surface, something to do with the binding of virus with the cellulose. With that, I like to conclude that we, as researchers, scientists and engineers, innovators and industrial experts, are trying to fight this, but we cannot do it alone. We all need your help to navigate through this. So thank you for listening. I will take any questions if you have now. So Laura?
Okay, thank you, Baig. Actually, we have a couple of minutes for a question, and I have one for you. So, other than for SARS-CoV treatment, has graphene been used in medical devices for other type of medical complications, for example, like in dentistry?
That's a very good question, actually. Graphene has shown to be biocompatible. So it works well with hydroxyapatite, which is a bone mineral found in our bones and enamels of teeth. And the literature is actually flooded with the hydroxyapatite graphene composite and hydroxyapatite with functionalized graphene composite, both experimental and simulation. And because graphene is biocompatible, it is shown to be biocompatible, remodeling of bones were seen to be effective. So it's a good way to increase the lost strength of the system. So yes, it has been used in dentistry and other part of the body also.
Okay, thank you, Baig. Thank you so much for your presentation.
Thank
And
you, Laura.
someone will join you in the Library of Knowledge working group to support you.
Okay, good to know.
If you can please mute yourself and turn off your video so we can continue to our next session. That it will be another working group on, I can see him already, on STEM education. So a really hot topic with Dr. Marco Corelli from Nano in the US chapter. So hi Marco, I can see you, I can hear.
Good morning, good afternoon, good evening.
Hi Marco, I can hear you loud and clear. So
can you hear me well? Fantastic. So thank you, Zina and Laura, for inviting me to speak at the AMPT conference. So I'm the founder of a nonprofit organization called Nano, and basically we teach students the science skills they need to get a good job after graduation. And we focus on this new field of science and engineering that is nanotechnology. So we envision, giving every student in the world the opportunity to learn nanotechnology through high quality textbook, online textbook and digital resources. And that's what I do all day. I kind of create, I love creating educational resources to teach nanotech to high school students, community college students, and basically inspire a new generation of scientists and engineers. Because when we show young students how they can solve the world problems using the science of nano, then they feel empowered to take action and invent new things. And I think you can go to the next slide, Laura. So with that in mind, we kind of came all together here and decided to compile a STEM working group within this community. So this was formed only a couple of weeks ago. Things are new, we're getting to know each other, but to make a difference in education based on what is going on in the world right now. But what is important is writing assignments, because students learn more when they do an assignment, when they have to, sit down and think of how to solve a problem, all these kind of things. So everything is going to be digital in format, it's going to be online. So once the activity is ready, we can distribute it to all over the world very quickly. So the distribution will be as a thin common cartridge. And these are kind of course packages that can be imported into the popular learning management system that schools use. So like Canvas is very popular in the US, Schoology for high schools, and there's a lot of them, but thin common cartridges can interface with everyone or almost everyone. What is important is that this activity must be, well, here in America it's called 508 compliant, and the name comes from a legislation, from a section on a legislation, piece of legislation. But 508 compliant means that people with disabilities can access the educational content without, too much trouble. So people that are visually impaired or hard of hearing, they can, their software can interface with our educational content and deliver somehow the content to them in a different format that, regular students are used to. So, of course, we'll start developing these resources in English, but then because they're digital, it's all HTML code, they can be translated into any other languages very quickly. Laura, can you go to the next slide, please? So, the working group is new, we just form it, and we need people to help. So if you are passionate about STEM education, and STEM for the European colleagues, STEM means science, technology, engineering, and math. So if you're about, passionate about like science and education, if you like creating lessons, if you like teaching, if you like interviewing people, if you have, editing skills of videos, if you like, to play around with video materials, or if you are a teacher, if you're teaching science classes, please consider joining the group. Feel free to email me and reach out to me in Slack. And, let me know what kind of new idea you want to bring into the group and how you can help making a difference in the world of science education. And I'm happy to take questions.
Great, thank you, Marco. Thank you so much for your presentation. And I actually have a question for you, because I think that if we're all here today is because somehow we were attracted by STEM and science. And so what I wanted to ask you is, how can AMPT and the working group on STEM education make STEM education more inclusive and to fill the diversity gap in STEM education regarding maybe gender gap or, country gap?
Yes. So, starting small, even with this activity, this is an activity that can be delivered to every school in the world, and each student in the world can access to it and have access to the same quality of education that, a student, I don't know, in London versus a student in Moldova, they'll have access to exactly the same education. Usually it's, what I find that nanotechnology, it's a field that kind of narrows the gender gap. Girls and, young women, they love nanotech.
I agree.
Because it's different from the traditional science disciplines like chemistry or physics, maybe where they are told, hey, this is for boys. But in nanotechnology, in biotech, it's a new thing. Everyone is welcome. And because nanotech, honestly, it's a field of science and engineering that aims at solving the world problems. Yes, we create new materials, but the ultimate goal is to solve a problem in the world. We don't make new materials just to put it on a shelf. They are useful to solve world problems. With masks, with water purification, with indoor air purification, with nanoparticle for CRISPR, gene editings, and so on. So I feel nanotech, this type of activities, the bridge bio-nano materials are more inclusive. And because of the way we deliver it, it would be the same for every student in the world.
Great. That is great to hear. So we're glad to have you on AMPT with your working group on STEM education. So thank you again, Marco. Please check the chat because there are a lot of questions for you. So,
absolutely, I will. Thank you, Laura. Thank you, Zina.
Thank you. Thank you. So I think we are ready for the next session. It will be a panel on cutting edge research. How can material science help fight global health emergencies? Moderated by Dr. Frank Koppens from ICFO, Spain, with Dr. Mauricio Terrones from Penn State University, US, and Dr. Jiaqing Huang from Northwestern University from US. So if you can all please turn on your video. Hi, Mauricio.
Hi, how are you?
I'm good, thank you. How are you doing?
Good, good.
I guess we're waiting for Frank and Jiaqing to join you.
Yeah.
Great.
You can see me? We have switched to my phone, so.
You have a moderator, so you're ready to start.
Okay, Jiaqing, you're there. Can you say something?
I don't hear Jiaxing.
Unmute. I'm waiting for the host to unmute me. Hi. My name is.
Okay.
Good to see
I'm
you.
only moderator. I have no powers to mute people.
I see.
Unfortunately.
Okay, so my name is Jiaxing Huan. I'm a professor of material science and engineering at Northwestern. I have a few slides to share, so not sure whether the organizers got it.
Yeah, so let's start with a brief introduction indeed. So
Okay.
you can, so maybe if you just, if also Mauricio can briefly introduce himself, and then Zhang, we go back to you where you
Sounds
can
good.
introduce your work with a slide. So Mauricio, can you briefly introduce yourself?
Yeah, so I'm Mauricio Terrones from Penn State University. I'm professor of physics and material sciences and chemistry as well. So these are my slides actually, but you want to go first, Yashin?
No, it's fine. You have the slides up, so
okay.
go ahead.
So
go ahead.
Yeah, let me just, we can go to the next slide, please. So the idea here is we develop a technology that we can trap viruses by size without an antibody, without a label. So what happens here is when the viruses mutate, usually the surface proteins change in time, and sometimes you have these antigenic mutations that in which maybe your antibodies are no longer effective, right? So you need to develop new antibodies in order when the viruses mutate, but the size does not change. So we develop a technology to trap viruses by size. Next slide. The technology, next slide, please. Or can I, okay. So can you just, basically we grow carbon nanotubes, which is rolled graphene. We use metal particles. So the next slide, so click once. So you grow the carbon nanotubes, and then we can grow on the right-hand side, you can see a track where we can grow the nanotubes where you have pre-patterned surfaces with this catalyst particles, and then you can control the intertubular distance of the carbon nanotube forests. And the metal particles here at the bottom of the slide, so you can see these metal particles a bit darker here. And by controlling the intertubular distance, we can trap viruses by size without any label. We create this and then we pack it with a polymer. Next one, next slide. So click once, please. Again, click another click. Click. So this is the microfluidic device. Click again. And this shows how the device works. So you have a forest of aligned carbon nanotubes that traps. So you collect your sample, which has the viruses, and you can basically have these intertubular distances. And the sizes of the viruses in this case is flu, or even the COVID-19 is around 100 nanometers. The COVID-19 is a bit larger, 125. But we can enrich samples. And the next slide. So click 3 times, please. Again. So so here is, we have H5N2 viruses that we developed this in 2016, and we can see the viruses that are trapped next to the carbon nanotubes and how effectively we can concentrate viruses of the sample. So this is a technology that we have used to identify viruses, and we have used PCR and next generation sequencing to identify these viruses. Let me just go to the quick, because I want to just give some time for discussion. So the idea is that you pass through all the sample, instead of just doing one volume of the sample where you have a few viruses and you do the PCR and sometimes you get lots of false negatives. Using our device, you pass through all the sample and then you concentrate the viruses, and then you can detect them. So this is the difference between this platform and others. The next slide. Next slide. I will not. So here is just, you can enrich a sample from for instance, you have the top one on the right-hand side, you have the pie chart, which is 1.6% of viruses. After passing through the device, you can enrich the samples and get 90 90.6% of the viruses. So you are enriching a sample and then you can detect it. And this is something that we have used for the next generation of technology that we developed just recently. Next slide. And we use Raman spectroscopy. So once we have concentrated these viruses, we put gold nanoparticles, and then we can then use Raman spectroscopy to see we can differentiate viruses because the surface proteins change from one virus type from the other. The next slide. Next slide. So here you have our label-free identification of viruses using Raman. And here you can see different types of viruses or subtypes of viruses have different Raman spectra, and then using a machine learning algorithm, we can identify them. The next slide. So here we have used this for human respiratory viruses. We published this actually in January 2020, so it was very timely with the current pandemic. And basically we have prime influenza, influenza, rhinoviruses, and you can differentiate the grouping of these peaks of these viruses. So you could, in principle, detect in, let's say, 1 or 2 minutes, you have enough virus samples and you have enriched them. You can detect and identify viruses. So this is a new technology. This is our recent work with coronaviruses from chicken, and we are just trapping the viruses from the chicken. Next slide. I just want to show quickly. And here we have the coronaviruses. We have the peaks of the coronaviruses, and we compare them with the other peaks of the other viruses, and they have very distinct peaks that, and this is preliminary work. So in principle, we can also identify and classify these viruses. Again, this is using our technology, machine learning, and this virus enrichment. So the platform could also work for other types of genomic sequencing, but this is just for a fast screening of samples. With that, I finish. Yeah.
Excellent. This is really impressive. A fantastic work. I know you worked on this for many years. For the non-specialist amongst us, it may look simple, but I know how difficult it is to work with nanotubes, and so this was really an impressive achievement. There is a quick question here from the audience. I will do that first, and then I go to Shajin. So one question was, how do you selectively capture different viruses?
So usually it's by size. So we have usually different viruses have different sizes and different shapes. But for instance, with this platform, we can make for instance, make different intertubular distances, and we can trap large viruses, medium size, and small viruses, and in different parts of the microfluidic device, and we could run Raman spectroscopy on the different sites. We have done also co-infection, so we have mixed 2 viruses, and you can identify one type and the other subtype using the machine learning. So we're working on that, but usually for human respiratory viruses, they are more or less, the size changes a little bit, but you have 2 types of viruses you could use in principle, especially with the coronavirus. You can distinguish coronaviruses from flu viruses, chicken flu viruses, for example.
Okay, very good, excellent. Let's go to Shajin. Okay. Maybe you can introduce yourself and introduce your work. Thank you very much, Mauricio.
Thank you.
Stay on the line. Yeah.
Okay. Well, so again, my name is Jarrahi Huan. I'm a professor at Northwestern, working in material science and engineering. Can you go to next? So we are new in this area. So in fact, I knew nothing about virus until the news about coronavirus broke this year. So what I did is that I'd like to share you basically my thought process and also our intellectual growth process. So what we did is that we started to study the basics of this, and we talk extensively to clinicians and public health workers. And we come up with a number of ideas and thoughts. We're working on some of those. And we're also sharing some of these, actually all of those with everyone. So I'd just like to start by saying that, how can materials help? So this is this diagram is just, this is a schematic to show the 3 necessary steps for the spreading of any infectious diseases. In fact, you can actually read a very nice description on CDC's website. So in particular for infectious respiratory diseases, everything starts with the source. So in this case, it can be a symptomatic or pre or asymptomatic carrier. Then the viruses are released from the source through droplets. And then there has to be a number of possible transmission pathways for this droplet to eventually reach the target. The target here is susceptible persons. Now, not everybody, in terms of infectious diseases, not every person Now, you need to identify those. You need to identify the source. You need to understand the transmission pathways. Now, all of these usually are studied by, let's say, people in public health, by clinicians, okay, and by people studying biology. But if you look at this schematic for a while, there's one thing that stands out. Respiratory diseases viruses, unlike other viruses, they have to spread across the physical environment. They have to spread across physical space. So if you go to the next slide. Okay. And if you look at the structure of the virus particles, now, again, bear in mind that this is a very sophisticated type of nanoparticles, as Horacio nicely put. He had much nicer structures over there. But I want you to appreciate that this is a very sophisticated structure. And from a material science paradigm, if we look at any materials, we need to understand the structure-property relationship. Why does it have to have such a sophisticated structure? Well, because all of these structures are meant to achieve 2 functions: protect and deliver genes. So you have proteins, you have capsid, you have nuclear capsid, etc., etc. All of these is to achieve these 2 purposes: protect the genes and deliver the genes. And they have to survive the entire physical space. So next slide. So since they have to spread across the physical space, right, physical distance, and it is a materials world, and we are material scientists. So there are actually many opportunities for us to set up barriers using physical sciences and engineering, and we can block and maybe deactivate the overwhelming majority of released viruses before they reach the host and breach the final biological and immunological defenses. So this is what motivated me to study this, because I think there are a lot of ways we can help and contribute, and that is summarized in that paper. Next slide. Okay, so the other thing I want to remind everyone that this is a general physical picture of viruses. We tend to think about viruses as individual nanoparticles, maybe dispersed in DI water. That's what we love to use in the lab setting. But in reality, if we just think about when we cough, right? Take a look at what you release. Viruses may even be an insignificant minority in terms of mass in what you released. So after water evaporates, we're dealing with this dried or semi-dried nuclei that contains lots of other things. So when we think about mitigation measures, we have to factor in all these other components. Okay, next. So in my lab, starting from February, we started to pursue 2 lines of research. The first line, we're focusing on chemical modulation of respiratory droplets. We're trying to make the sources less infectious. We're not making better masks to protect the wearer, because we are actually trying to make an add-on or any kinds of modification layer to make the sources less infectious. So also thinking about back to the slide 1, that anything we do in a larger scale, we should address one of those 3 key elements: the source, the pathway, and the target. The second project is about self-sanitizing coating for stainless steels, and this is to address the spreading chain. We're trying to cut down the possibility of fomiting infections. So someone mentioned also early on that coronaviruses were found to be extremely stable on stainless steel surfaces. And this is very problematic because we use stainless steels everywhere. So we were able to get one NSF Rapid Award on this, but most other work were actually based on repurposing, was supported by repurposed existing grant. So we're grateful for the funding agencies that they agreed to let us drop everything else we were doing to refocus on research for the coronavirus. For me, it's a risk as well because we're not necessarily getting a ton of extra funding on this, but my students, my team members, and myself, we all agree that this is above and beyond ourselves. Let's get this done first, and before thinking about our other research. Okay. So these are the team members, including one graduate student, postdocs, and a research associate. Okay. I think my time is up, and maybe the next slide just to show you where you can find additional information. Okay. This is the perspective article we wrote, which is published 2 months ago, and it has a dozen of ideas in that Zina nicely put as a poster. And if you want to find out more about the authors, that's the next slide. These are the authors and clinicians, public health workers in that paper, and we have a brief introduction about them in that paper. Okay, thank you.
Thank you very much. That's a great picture. We should do this actually with all the participants. The 87 people are online.
Yeah.
Okay, thank you very
Ideas
much.
can spread. Yeah. Okay.
Exactly. Let me start straight away with you, because you're also on the steering committee. So for you, this must also be a win-win situation because you're so embedded in this research now, which, by the way, you switched really rapidly, and it's amazing how fast you got it. So, but that's just you and your group. But how can we how can you take advantage of AMPT? How do you see AMPT being tailored such that it can really benefit the type of research that you're doing, and also the world can really benefit from the work?
Okay. So you were a little bit cut off, but I think what you asked is that how do we amplify things like this, what we do, right, to benefit as many people as possible. So
yes.
One thing I did in here is that because I wasn't an expert at all, but through learning, I realized that even if you were not an expert, you can actually identify problems and then develop solutions for that, at least hypotheses. And that's why we worked day and night at that time. This is in early March. We put out this perspective. It's not about just bragging about what we have done. We actually haven't done anything at that time. It's about presenting a dozen of ideas of what needs to be done. And these are the problems that are verified by these frontline clinicians. So they basically provide like a map of need, okay? And once you understand these needs, I'm sure there are tons of smart people out there, and much smarter than me out there, that you can connect your expertise to solve these problems. And in terms of problems, there are twofold. One will be local problems that's unique to your community. One will be a larger scale problems. So in this paper, we were focusing on the larger scale, which is again to address the 3 key elements. Can we come up with any materials idea to cut down the source of transmission? Identify and cut down the source, and can we do anything try to cut down the chain of spread, and can we do anything to specifically protect the susceptible group of people? So I think if we align our expertise to these 3 big steps of 3 key elements, that will be the let's say that tend to have a longer term impact. But that being said, there are tons of problems that unique to your own community. And I also urge everybody to talk to people who can give you, provide the, enrich the map of need, right? And then connect your expertise to that.
Okay, that's a great one. And I'm glad to hear that AMPT is doing this already. What I would like to see is a visible effect very soon, right? Because we need to stop transmission now. It is clear that not all the politicians are listening to the scientists, right? So how can we, as AMPT, make a visible impact in short time? And I'm talking about within 1 or 2 months that we really can see we are affecting this transmission through the work that you are doing or your colleagues?
Okay, is that question for me or for?
That's a question for you. Yeah. So I'm
okay.
putting you
Okay.
here on the spot.
Yes. I'm not an expert in politics, but I believe that regardless of the ideology and political system, politicians should serve the people. And if we cannot deliver the message to the people through politicians, then we scientists should feel empowered. We should equip ourselves and deliver the message directly to people. So for example, should we wear a mask? Something as simple as this, I was shocked to find out that something as simple as that seemed to be in a mess, right? But so what we hope to do through our project, and as a funded one, which we are now drafting up the manuscript based on our discovery, is really to emphasize that a mask is not just to protect yourself. You don't have to feel less manly to wear a mask, because wearing a mask is a gracious respect to people around you. It's a politeness, it's a respect to others. It's not about chicken out, afraid of viruses attacking you. It's actually being super considerate and super caring for others. And I think that pitch, I hope more people accept that.
Okay, that's a great pitch, and hopefully AMPT can help to also communicate that pitch to the outside world. So, okay, let's go to Mauricio. So, your work seems extremely promising. It looks like, you know, this should go straight to the market. How close are we now actually to get this to the market, and what is hindering you to take this in short term to the market, and how could AMPT network help you to speed up bringing your technology to higher matureness and to the market?
That's a very good question. So I think we are at the phase of where we have the prototypes, right? So we are trying now to see, the next step would be to try to do some experiments with the COVID-19, right? But we need to access a BSL-free facility, and it's more complicated to get a Raman spectrometer in there. But right now, at the moment, we need to develop the cartridge for specific applications. And the idea is that maybe you can have Raman spectrometers at the airports, but the idea is to develop the cartridge. So for that, we need to work with companies in order to have FDA approval of this. And we need to then scale the production of this. And this takes, I don't think it will be ready for the current pandemic. But I think this current pandemic will basically change the way we travel, the way we interact with other people in the future, because the virus will mutate and maybe other viruses will emerge. So in terms of commercialization, I think we're a bit far, but I think if we have the funding and the resources, we could get this up to speed in let's say, in all best possible conditions, maybe in 1 year we could have a prototype which is approved, right? That we can start commercializing. But again, you need these cartridges, because these cartridges will be for one person at a time, but it has many multifunctionalities. Besides, you are concentrating a sample from a patient, and that can be then, after screening with Raman, you can use it for other genomic identification, even virus replication, vaccine development. So it has different applications, and then we're talking to some companies, but if the network can find other people that are interested also in Europe, that would be great.
Okay, so you think the network can help you to find these connections? Do you have any suggestions on how the network could help you to speed up this technology, perhaps with funding, finding funding?
Yeah, we need to talk to the players and stakeholders, right? So if we start discussing that, we can see how we can help each other. I mean, this platform also has a very important component of data science and machine learning, which you need to set up a database, maybe at the world level, and then you can monitor patients with the same technology, right? But the more data you put in the database, the better the performance will be, because we can differentiate viruses from others.
So still, the timeline you give is quite fast. So within the Graphene Flagship, we have a lot of discussions about the supply chain, which is complicated to set up for a new material. So here we're talking really about an advanced material network. So we are facing also this challenge to set up a supply chain, and to do this as a larger team makes it much more efficient than doing this as an individual. So how do you see the creation of the supply chain here, in this case, in your type of technology?
So for the supply chain, I think we need to talk to manufacturers. We need to talk to then these manufacturers that could reach, FDA and get approved in a reasonable manner. And then from there, we need also Raman spectrometers, manufacturers, even developing portable Raman. So you have the base technology, the spectrometers. You have the other technology, which is the cartridge production, and then you have the data science, and you have also a component of virology and infectious diseases. So all these take part of your supply chain.
Okay, so I'm to get manufacturers on board.
Yeah.
Justin, you have.
I have one quick word is that maybe switch the mindset for scientists. Switch a mindset about, we used to think that when we publish a paper, we are the best in the world. But now when we publish a paper in this topic, this is going to be the beginning of a new idea. And that's what we're going to do for all of our papers. Here's what we think it is. Here's the scientific foundation, but this may not be the final solution. Please go ahead and take this and develop your own. I think that would be maybe a quick way to achieve the impact, right?
Okay.
Once the knowledge is out there, it's okay. It's free to use.
So I'm going to take your word for this. I don't know if you said that, but you're going to change the mindset of scientists, which seems like a big challenge.
Start from ourselves. Okay.
We start with ourselves. Well, okay. So this is a really great discussion. Zina or Laura, do I still have time, or do we need to wrap up?
Well, I think it's time to wrap up, and we have also one last question for Professor Juan. I see in the chat.
Oh, okay. Let's see where I was disconnected briefly. So can you repeat the question for me?
What's your take on about AMPT? That's the question.
AMPT, I think it's a very exciting initiative. It's a grassroots initiative. And I think this will be a tremendous inspiration to connect people all over the world with similar aspirations together. So I'm in support of these. That's why I am in the steering committee. And I hope more people can share the vision of AMPT and join us. Okay.
Great, thank you.
Wonderful. Okay, thank you. Thank you very much. Yep.
Thank you.
Okay, thank you, Marisha. Thank you, Justin. This was a really great discussion, and congratulations with a fantastic work.
Thank you.
All right, bye.
Thank you. Thank you again. Please mute yourself and turn off your video so we can start our last session with the working group partnership engagement with Dr. Raquel Almeida from IPS, Institute for Research and Innovation in Health from Portugal. Hi, Raquel, I can see you.
Can you listen well?
Yeah, loud and clear. So the floor is yours.
Thanks, Laura, for the introduction, and thanks, Zina, for having me here today. So just a brief introduction of myself. I'm a biomedical scientist, a biologist by training, and I have a PhD in bioengineering. I started working with graphene just 1 year ago, so the field of advanced materials is quite new to me, but the project of AMPT is quite exciting, and that's why I decided to come on board. So today I will be speaking a bit about the work that we are developing within the Partnership Engagement Working Group, which I am co-leading together with Kimberly King from Human Tech and One Island Institute. And it's a bit hard to speak at the end after everyone else, but the others already gave a lot of insights about what will be our work and our mission as a working group. So our working group is relatively young. We started a few weeks ago, and it was born as a need from AMPT network, which basically started as a few individuals and is growing to engage different institutions at different levels. So as you can see here, our mission focuses on the creation of a stakeholder map and on the identification of key partners, as well as on the establishment of frameworks and different tools to engage these institutions and enable unique collaborative pathways that will allow synergistic and mutual development within this AMPT ecosystem. Next slide, please, Laura. So we will support our, it's not pretty, never mind. We will support our partners to navigate the AMPT network, and our working group will feed directly, as you saw, to other working groups like the roadmap, the map of needs, the applied public health, library of knowledge, and STEM education, and many others that might appear in the meantime. And we will be able to feed these working groups with different resources and different expertise so that we can move forward with technology development within AMPT project. And at this stage, our first priority partners are basically scientists and associated institutions like universities, scientific societies, and publishers, so that we can bring together sufficient critical mass to advance knowledge and to translate this into innovation. But we will also be targeting NGOs and startups, and at a later stage, of course, different industrial partners like manufacturing and so on, as you saw previously mentioned, so that we will be able to actually translate this into a value chain and into market. In this sense, just to give you an example, one of the things that we aim to launch at least soon is the creation of an expertise database, so that we can generate matchmaking profiles based on knowledge and resources for to allow the development of these technologies further. So imagine you are a scientist in biohealth like myself, looking for an advanced materials partner. What we want is to bring you on board and connect all these different parts together and push forward these solutions for the betterment of human life and for a better future. Laura, can you move to the next slide, please? Okay, thanks. So just to close up, if you are part of AMPT already as an individual and you want your institution to get more involved within the task force, or even if you are outside AMPT and are searching for a way to support us, either through your scientific expertise or as a financial support, as we already saw in the chat, you will be able to contact us. We are creating these partnerships at amptnetwork.com email probably this week, but you can reach out to myself or Kimberly directly to explore the different possibilities in terms of partnerships and engagement within AMPT network. So we look forward to engaging internally with all our AMPT members and working groups, and we would like to learn from these different working groups and share wherever resources come to our hands, and of course to engage partners as we grow as a community to improve human life. Thanks.
Thank you, Raquel. So I just had one question for you.
Yeah.
And I mean, what are your short-term goals for your working group? What do you see in the near future?
So our first goal is to create this database that I feel will feed all the network and will be the foundation to create and to sustain the task force in the long term. Meaning, we need to organize ourselves and to be able to identify what are the key gaps in terms of knowledge and in terms of resources, so that we can all together advance these solutions that we propose to develop in the near future.
Okay, great. Thank you, Raquel. I think this was the best way to conclude our event, because you're really collecting everything that we are doing. You're trying to give the scientists and the world something to do with this. So thank you, Raquel, for your presentation. And if you can turn off your video and mute yourself. So, okay, we just concluded our event. So I will leave the floor to Zina. So she will make her final remarks.
Thank you, Laura, and thank you, everyone. This was exciting, 3.5 hours, over 20 speakers, and we heard from many of our working groups. I wanted to thank you all for being here with us. I wanted to thank all of our regional chapters and working groups. AMPT would not have existed without you guys. It is nothing without the people who are actually building this, and we're each bringing a piece of the puzzle to the table. And I say this puzzle is a picture of a treasure map. There's going to be a piece for everyone, but we need to bring these pieces together to be able to, for all of us to see this bigger vision. I really appreciate your participation, and I hope that you got a glimpse into what AMPT is trying to do. We really like to interact and partner with anyone who is interested. Contact us directly or contact the working group members that you have seen. And I wish you the best. And this is only the first one of our events. Hopefully the next one will have it in person, but if not, we'll have another virtual event where you can learn more about AMPT, and hopefully many of you by that time are going to be involved in this. I want to thank Laura. Laura, you've been fantastic, because I can see Laura sitting right there. So Laura, we finished on time. I mean, this is unprecedented. To be honest, yes, it's unbelievable. And thank you to everybody who was in this room. Thank you, John. Thank you, Kazi. You guys are rock. Thank you all of our working group members, and enjoy your day or your night and join us. Thank you all.